Hello dear students, welcome to IMS Gate Academy. I hope you all are good guys, and today we are here to analyze and provide you detailed exam solution of GATE EE 2023 exam. So our IMS Gate Academy mentors also appeared for the GATE exam just for have a look of exam and to memorize some question so that we can have a detailed analysis just after the 30 minutes of GATE exam. So according to our mentors, they have experienced, we can say that the GATE EE 2023 exam is quite tough. It is not moderate, it is not easy, it is tough as compared to last years. And what is the basic the difference between the last 1 or 2 year and this year? Last 1 year there was no MSQ in the EE, but this time we have a different. Here we have a types of questions in today's GATE 23 EE GATE exam that was conducted on 5th Feb, that is today, and timing was forenoon session 9:30 to 12:30, and right now 1 p.m. we are having a detailed analysis. So we are having MCQ 40, NAT 20 and MSQ 5. Earlier in 21, in 22, there was no MSQ for EE students, but this is the first time in GATE 23 GATE exam, in 23 GATE exam, IIT Kanpur provided 5 MSQ, that NAT 20 and MCQ 40. Of course, in the MCQ we have a negative marking, but the advantage for NAT and MSQ, there is no negative marking. But still, in the numerically answered question, you don't have an opportunity to eliminate the options. So I just want to, I'm going to solve here signal system question, control, digital also very soon. But before that, before inviting to other mentors also, Priyanka ma'am going to solve the questions of engineering, mathematics, aptitude. We all are ready to provide you the detailed solution with the proper difficulty level, each and everything we are going to discuss here. But I want from your side, this is the only thing, please share this session so that other aspirants also will get the information. Now IMS GATE Academy is live on our YouTube channel, on their YouTube channel, and my dear student will provide you the complete detailed solutions. Okay. So I would like to invite, or some faculty members already got some network question, analog questions also. Once I will see, because I have just completed other webinar also. So right now, I am just inviting to my next colleague, okay, that is Mr. Subodh. So Mr. Subodh sir, please come, and I would also like to ask something from you regarding the today's difficulty level of exam. However, many students saying that the question is even not moderate, it is a tough question. It is a tough question. And IMS GATE Academy going to provide you the complete detailed analysis. Yesterday also we have conducted 2 live event, more than 5 hour, more than even 4 hour live event for computer science and mechanical stream. Similarly, we are also conducting EE as well as for EC. So student, math and aptitude question about to come very soon. Meanwhile, you should share this session maximum. So just come, Subodh sir, and tell me, according to you, what is the level of today's GATE 23 EE exam?
Yeah, thank you, sir. So actually, as I have seen till now, so question is very difficult as compared to previous one. Yeah, and the reason behind this is what? So first of all, the MCQ questions.
MSQ.
Yeah, MSQ multiple.
MSQ question.
Yeah,
this is the first time
yeah,
MSQ
so
came. Correct.
In the previous year there was 0 MSQ.
0 MSQ.
Yeah, but here 5.
Correct.
And you can see here also this data.
20 numerical answer questions.
Yeah,
yes,
and it is creating difficulties level.
Exactly,
yeah.
Exactly.
So that's why the paper is you can say moderate to difficult.
But even some students are saying not moderate, sir.
Yeah,
it's difficult only.
It's difficult only. Exactly.
Okay,
and due to this only, sir, the reason behind this is
now you
out
are
of 65, there are 25 questions from NIT and MSQ
and
only.
that is also a good thing.
Yeah.
But that, however, here no negative marking, but still student has a confusion because no scope of option elimination.
Exactly. So, because there are multiple options in MSQ and here you don't have any.
Very good.
Yeah.
So how many questions you are ready with, and you are solving first question?
Yes, so from network theory.
So okay, guys. So network theory question we are going to solve. Just motivate our students so that they can share it to the maximum.
Exactly, sir. Because what the question came now. So many of the questions are from previously we have discussed similar questions. Many questions we have discussed.
Also,
exactly.
Good.
Yeah. So,
so over to you. Just to continue for network questions.
Yeah, exactly, sir. So let us start, students. So first question I'm just taking from network theory, and here you can see the question. Yeah. So if I'm talking about the first question, guys. So this is from network theory, and the question is, and if there is any correction, you need to correct this one, okay? Because what we got data from the students, I'm just discussing here, okay? So the question is, there is 2 resistance, one is of 0.5 ohm, and this is of 3 ohm, guys, okay, and here we have a current source. Here we have a current source which is connected with another resistance, okay, and it is now connected with a wire, okay, and here we have one more resistance. Is it clear? And the value of this resistance is 2 ohm. This is also 2 ohm, and here we have one more resistance, guys, of the value which is 3 ohm, okay, and here we have voltage of value V1, guys, okay, and this current is I1. Is it clear? So just check all of you, and please tell me, comment here, is this circuit diagram is correct, yes or no? Just respond please, okay. So the given data is correct, yes or no? Here for the given question you have data, you have given data which is this voltage V1, this voltage V1 is equal to 8 volt, and the current I1, this current I1 is given to you which is 8 ampere, guys. So this data is given to you, this data is given to you. Now now what we have to calculate, we have to calculate this voltage, guys. So this terminal voltage is given to you VA, and this voltage is given to you VB. What you have to calculate, you have to calculate VAB is equal to what, sir? Is it clear, yes or no? Just tell me please. Is this question is correct, yes or no? Just tell me please, okay. So this is the question, guys. If it is the question, what we have to calculate, we have to calculate this value of VAB, guys, okay now. So actually we have discussed this type of questions many times, guys, okay. Now if I'm talking about the solutions, so how to solve these questions, guys? So here you can take reference, or we can say you can take ground at any terminal, guys, okay now. So here we are just taking this as ground terminal, okay now. When you are taking this as a ground terminal, so this will be how much, sir? This will be grounded only. This will be grounded because it is connected with a sorted wire. Is it clear, yes or no? Okay. Now what I am doing, if this voltage is 0, so obviously this voltage will be how much, sir? This one is V1, okay. Okay, so is it audible and visible, guys? Sorry for the interruptions. Is it audible and visible? Just tell me please. Okay, sorry for interruption, guys. Okay, so here I am talking about KCL at node A, guys, okay. So I am writing KCL at node VA. So what we can write here, if I am talking about this point, guys, so this is the incoming current. So incoming current is V1 minus of VA, and this divided by how much, sir? So this divided by 0.5. Is it clear? Now at this point what we can write, sir? So this is equal to outgoing current, and the value of outgoing current is VA minus of 0, and this divided by how much, sir? So this is equal to 3, and here we can write this is VA minus of 0, and this divided by 3. Is it clear, yes or no? Just respond please, guys. Respond all of you. Is it clear? Yeah, Suman is saying it's C, okay. So let us see, Suman, okay. 6 is the correct answer, okay. Let us see. So here what I am saying, so this is VA minus V1 minus VA divided by 0.5, and I am just taking LCM. So this is equal to 3. So it is how much, guys? So this will be 2 times V of A, okay. So just cross multiply this one. So we can write this is 3 times VA minus of 3 times VA, which is equal to VA, guys. So here the value is 3 VA is equal to how much, guys? So this is 4 times VA. Is it clear, yes or no? So what we have to calculate, we have to calculate the value VA. So VA is equal to 3 times V1 divided by 4. So what is the value of V1, sir? So V1 is value is given to you. So this is 3 into 8, and this divided by 4. So this is how much, sir? So this is 2. So this will be 6 volts, sir. So it's very simple now. If it is 6 volts, then what we can write, guys? So VAB is equal to how much, sir? So this is equal to VA minus of VB. So this is equal to 6 minus VB is how much, sir? So this is 0. So this is equal to 6, guys. So 6 volts is the correct answer. 6 volts is the correct answer, guys. So respond here, guys. Okay. So next question is from transient analysis, guys. So here what we had to calculate, so in this question you have given this circuit, guys. Okay, so here you have given a resistor and it is connected in series with an inductor. Okay, and here again we are having one resistor, guys, which is connected with the capacitor. Okay, now this circuit is connected with a switch, guys. Here we have one switch and this is connected with one resistor, sir. Okay, is it clear? And we are having one current source here of the value 10 ampere, guys, of the value 10 ampere, and this is 3 ohm. This is 3 ohm, and this switch is closed. This switch is initially closed and opened at t is equal to 0, sir. Opened at t is equal to 0. Is it clear? Now if I am talking about this, so what we have actually, so here this is 2 ohm, this is 100 microfarad, and this value is 2 ohm, and this is what, guys? This is 10 millihenry. 10 millihenry. Okay, and this current is given to you. Okay, actually no. So here this voltage we have to calculate. This voltage we have to calculate, guys. Is it correct? Yes or no? Respond, please. Just respond, all of you. Is this circuit is correct now? Okay, so just check how many of you got the correct answer what I am solving here. Okay, now what you have given, so for this you have given for t less than 0 the circuit, or we can say the switch was what, guys? Closed, or circuit is in steady state. Circuit is in steady state, guys. Okay, and for t greater than 0 the switch is open. Okay, so switch is open. The switch is opened, guys. Okay, and what you have to calculate? So you have to calculate VL0 plus is equal to what, sir? VL0 plus is equal to what? Is it clear? Yes or no? Is it clear? Yes or no? So here how to calculate this value, guys? Just tell me, please. So if I am talking about this question, sir, so here we are having RL and C circuit, guys. Okay na? So for this given RLC circuit, you have to calculate this value of voltage at t is equal to 0 plus. Is it clear? Yes or no? So to find this value, just we have to calculate initial values, guys, and directly we can find at t is equal to 0 plus only. Okay, or you can find by other method also. Okay na? So let us do by this simplest method, guys. So what I am doing here, we are finding for this condition only. So for t less than 0, if I am talking about the first case, so for t less than 0, the switch is what, guys? Closed. So the given switch is closed, guys. The given switch is closed. Is it clear? Yes or no? And if it is closed and it is given to you, this circuit is in steady state, guys. This circuit is in steady state. So obviously in steady state, this inductor will behave like what, guys? So this will behave like short circuit, and if I am talking about the capacitor, so this capacitor will behave like open circuit, guys. Is it clear? Yes or no? Okay, so now let us draw this circuit again, guys. So how to draw this? So this switch is actually closed, so we can write this is closed circuit which is connected with a 3 ohm resistor, guys. 3 ohm resistor, and here this current is off and the direction of the current is this only. Okay, so here the direction of the current is this. So this is 10 ampere. Okay, and now here we have this circuit and this resistance is connected with the inductor which will be short circuited, and here this resistor is connected with the open circuited, guys. Is it clear? So this is 3 ohm, this is 10, and this value is given to you which is 2 ohm, and this value is given to you, this is 2 ohm. So here if I'm talking about this value guys, so obviously this will be IL 0 minus, and if I'm talking about this, so this will be VC 0 minus, sir. Is it clear, yes or no? Just tell me please. Is it clear? Very good, very good. Okay, so just respond guys. How many of you got the correct answer? Just see and respond. How many of you got the correct answer? Is it clear? And if you are getting any new questions, just comment here also. I will give you perfect explanation guys. Yeah. Okay, very good. So here what I'm saying guys, so just we have to calculate this value of IL 0 minus and VC 0 minus. Then what we'll do guys, then find that t is equal to 0 plus directly. Is it clear, yes or no? So what I'm doing here guys, so actually this current is divided in two parts. So this is the one part and this one is the second part guys. Because this current will be 0, so we can say this current is divided in two parts guys, for 2 ohm and 3 ohm. This will be divided. So we can directly apply what guys, current division here to find this IL 0 minus guys. So I'm writing directly here. What we can write? We can write IL 0 minus is equal to, this is 10 ampere and this is what guys? So this will be 3 and this divided by total resistance, which is 3 plus 2, which is 5 guys. Okay, so this current will be how much guys? So this will be 6 ampere. This will be 6 ampere guys. Is it clear, yes or no? And if it is clear, so we can write this value of VC 0 minus also. Is it clear, yes or no? We can write this value of VC 0 minus. How? So just see here. What we can write, we have discussed this type of questions many times guys. If you see in this YouTube channel only, we have discussed many times this type of questions. Is it okay? So it is very simple sir. If I'm talking about the VC 0 minus, so VC 0 minus is equal to how much sir? So obviously this voltage will be equal to voltage across this resistor only. Is it clear now? Because there is 0 drop guys. This current is 0. Is it okay? So what we can write? We can write VC 0 minus is equal to IL 0 minus into 2 guys. Is it okay now? So what we can write? We can write 6 into 2. So this is what guys? Voltage across this. So this will be 12 volts sir. 12 volts guys. Is it clear? Is it clear? Now what I'm what I'm doing guys, so I am again drawing this circuit at a t is equal to 0 plus guys. Okay, because what we have to calculate, we have to find this value of voltage across this inductor at t is equal to 0 plus. Is it clear now? So let us find this value at t is equal to 0 plus. So as I have to calculate at t is equal to 0 plus, so at t is equal to 0 plus, what will happen guys? So here this switch will be opened guys. Okay, so we can write switch will be opened. This switch will be opened. And if I am talking about inductor sir, so this inductor will be replaced by, so this is replaced by initial values guys. Okay, and if I am talking about the capacitor, so again this is replaced by initial value, or we can write initial condition. Okay now, so you can write IL 0 minus here. Okay, and here this will be replaced by VC 0 minus value guys. Is it okay? Is it okay here guys? So let us draw this circuit again. So what we can write here, so this will be open circuited guys here. In this case, this will be open circuited. So let us draw this. So here, this will be open circuited. And this current is again 10 ampere and it is connected with this guys. Okay. So now as we have what guys? As we have voltage source. Why? Because initially we have what guys? Capacitor. And this capacitor will behave like what guys? Behave like short circuit and replaced by initial values guys. Replaced by initial values. So that what we can say here guys? So we can say here this will be replaced by the voltage source of the value VC 0 minus guys. And if I am talking about this inductor, so the inductor is open circuit and replaced by the IL 0 minus guys. Okay, now this circuit is very simple and you can say the circuit is very simple circuit and we can find the current value easily or voltage value easily guys. Okay, so just write the value guys. So this is 10 ampere and this value of resistance, if I'm talking about the value, so this is 2 ohm, 2 ohm, so we can write this is 2 ohm, 2 ohm, and the voltage of this is how much, sir? So just we have calculated this value, so this is 12 and 6 ampere. So this is 12 volt and 6 ampere, sir. Is it clear, yes or no? Okay, so it's now very simple. What we have to calculate here, sir? So just we have to calculate this voltage VL0 plus, sir. This we have to calculate only. Is it clear? So for finding this, what we have to do, guys, just write KVL in this mesh, guys. Okay, so I'm writing KVL here. Write KVL here. So what is the value, sir? So here, as we have, the current is how much, sir? So this current will be 0. So this current is 10 ampere. So this will flow here, guys. Okay, na? If this will flow here and this current is 6 ampere, so obviously this 4 ampere will flow here only. Okay, na? So if you apply KCL here, this will satisfy. Is it okay now? Now what we can write here? So we can write KVL here, guys. So the KVL value is what? So this is 6 into 2. So this is 12 plus of VL0 plus, and this is minus of 12, and this is what, sir? So the direction is, or we can write polarity is this. So we can write minus of 4 into 2. So this will be 8, and this is equal to 0, sir. So this and this will cancel out. So we can write VL0 plus is equal to 8 volts, sir. And this is the correct answer. This is the correct answer. Is it clear, yes or no? Okay, so if I'm talking about the network question, guys, so till now what we have just find questions, what we get questions is very simple, or we can say moderate questions, guys. It is not very tough. Okay, so we'll discuss many questions here, all the questions here one by one what we got, and I just want to give you perfect solutions, guys, with the accuracy. Accurate questions will solve here with the accurate answer also. So just we have to wait and watch. Okay, guys, so we'll discuss all the questions here. Okay, so next Ankur sir is coming to discuss the subjects. Okay, now remaining questions. Okay, so just watch this session continues.
Okay.
Okay, yeah.
Okay, thank you.
Yeah.
So my dear students, just let me know audio video is clear. Just share it, guys, to maximum, so the maximum student get benefit. Okay, we are live at IMS Get Academy YouTube channel with most accurate data, and I am going to solve a control system beautiful question. The question is here, whatever the given data I have, according to, I am writing the question here, guys. You just confirm it whether the data is correct or not. Question is, the question is here. Okay, the question is, my dear student, here state matrix A is given to you. The state matrix A given, that is 0, 1, -1 and -2. This is the A matrix given, guys, and the B matrix given state variable question. It is very easy type of question because simple mathematics include here. If you like mathematics, you can definitely secure 2 out of 2 marks. It was a 2 marks question. 3 minus 2, and D matrix is also given. In general, D matrix generally 0, but here D matrix is given. Now examiner is asking that for input xt, that is given, for input xt that is given sin omega t, input sin omega t that is given, for input sin omega t, find frequency omega, for which steady state value of the output is 0. Just confirm it. Steady state value of output yt is 0 or becomes 0. So this is like question, guys. This is the question which is given in the gate. Just confirm it. This was the question or not. Just confirm how many of you guys appeared for the gate exam today. Now student, this is also important for EC and IN also, those who have a subject control system in the syllabus. Now this is the question, dear student. Now whenever such type of question will come, first of all we have to find out the transfer function. Okay, So if I talk about the transfer function, because here two concepts involved, first you need to calculate the transfer function, and after that you have to apply that concept that whenever any sinusoidal input is applied to a system, the output is also sinusoidal but having different magnitude and phase. Because the output is 0, it means whatever the magnitude of transfer function, you have to make it 0. So these are the two concepts. The first of all, you have to find out the transfer function, because here we have a two concepts, sir. This is what the transfer function here, and this is what the input sine of t, x of t equal to sine of omega t. And you know that if input is sinusoidal, then output is also sinusoidal. For LTI system, tough paper, very good AM, that is true only, paper is tough, but this control system question is a easy question. You can easily secure 2 marks question here. If you have not secured 2 marks question, it means you don't have a good concepts of control system. My classroom student can easily solve this 2 marks question, that I can sure. For x equal to sine omega 2, output can be a sine omega t plus phi. Amplitude and phase can only change, frequency will remain same. But first of all, we are looking for this transfer function, and as far as state variable method is concerned, the transfer function formula will be c dot si inverse dot b plus d. So this is the only transfer function, guys. This is the only transfer function. I hope you guys getting the same. I hope you all guys getting the same. So this is my transfer function. So now I am looking for first of all Si minus A. And do you know what is A matrix, guys? Do you know what is A matrix? The A matrix is given as 0, 1, minus 1, minus 2. So here you will get S minus 1. Sign will change now. So sign will change. So here minus to plus, or यहाँ पे S plus. So here is plus 1 and here is S plus 2. So I think this is Si minus A. You got the point, guys. How many of you got this Si minus A? How many of you got this Si minus A? Tell me yes or no. So S minus 1 plus 1 and S plus 2. If I talk about directly Si minus A inverse, how many of you know direct method? I told you in my classes, you can directly find adjoint upon determinant. And what is adjoint? You can just interchange it and just change the sign of this. So when you will interchange, you will get S plus 2 S here, and when you will change the sign, you will get plus 1 here, minus 1 here. And again you have to divide with the determinant. And what is determinant? S into S plus 2 matlab S square plus 2S and plus minus minus plus 1. Yeah. So it means what you can write, this is nothing but S plus 1 whole square. So I am writing here only S plus 1 ka whole square, and this data as it is, that is S plus 2 plus 1 minus 1 and S. And now I need to multiply with this Si minus A inverse dot B. So I am multiplying this Si minus A inverse into B. So what is the B matrix, guys? Given in the question, the B matrix was 0, 1 only. So when you will multiply it, ultimately you will get 1 upon S plus 1 whole square is outside only. 1 upon S plus 1 whole square is outside only. S plus 2 into 0, 0. 1 into 1, 1. So you will get 1 here. Again minus 1 into 0, and here you will get S. So you will get here S. I think 1 and S. So this is the complete term which is equivalent to Si minus A inverse into B. Now student, tell me what you will multiply. You should multiply with C also. So when you will multiply with C now, what you will get? You will get this C into Si minus A inverse dot B. So what will be C, guys? What will be C? Here C matrix is also given, that is 3 minus 2. That is 3 minus 2. Yes or no, guys? 3 minus 2. So I am writing here 3 minus 2. And of course, I am also writing here 1 and S. 1 and S. I am writing here 1 S. And whole bracket are also I am writing here 1 into S square. S plus 1 ka whole square. 1 upon S plus 1 ka whole square. Yeah. Now tell me, my dear student, what you will get? 3 into minus 2s. So you will ultimately get 3 minus 2s upon s plus 1 whole square. S plus 1 whole square. And it is nothing but still C dot Si minus A inverse dot B. And I hope my dear student, many students generally they neglect the D part, because in general D actually is 0, but in this question D matrix is given to you, guys. So in general this is the transfer function, but for this particular question the transfer function will be, because the actual formula of the transfer function. So dear student, tell me now, if I want to find out the final transfer function, it can be what? C dot Si minus A inverse here plus D is 1. So I am writing here 3 minus 2s. I am writing here 3 minus 2s upon S plus 1 whole square, upon S plus 1 whole square plus d. And do you know what is d? D 1. So now it will give you final transfer function. It means it is nothing but your ys upon x of s. It is nothing but your ys upon x of s. So when you will take the LCM, what you will get, guys? Your LCM will be s plus 1 whole square. Now here you will get 3 minus 2s and plus s plus 1 whole square. So can I open it s plus 1 whole square? Yes sir, you can open. So when you will open, you will get s square plus 2s plus 1. So ultimately numerator part will be this 2s and 2s get cancelled out, sir, and you will get s square plus 4. You will get s square plus 4 upon s plus 1 ka whole square. Now student, this is my transfer function. This is the one concept, and this is the second concept as I told you. This is the second concept as I told you. Yes, second concept. Now I am again taking in one more slide and I am writing this now. Then what is the next concept now? Now you having it. These are the two concepts involved here. That is why it is a good question, guys. That is why it is a good question, because two concepts involved here. S square plus 4 upon, I am writing here s square plus 4 upon s plus 1 whole square. So many the faculties will not give you proper answer. They will tell ki ye aage you can calculate. No student, even if you don't, even some if someone don't know the answer, they will not explain, because student, we have already solved such type of question many time in the classes. Even you also know this concept, so you can easily calculate it. And we are solving a provide detailed solution. We are not providing any incomplete solution here. Okay, we are not providing like if we have solved 60% question and after 40% now you can solve it. No, we will solve each and every step here, guys. Do reply fast. If xt is sin omega t, if xt is sin omega t, then the concept says that if a sinusoidal input is applied to a system, then output is also sinusoidal. Then output is also sinusoidal, but having different frequency and phase. How many of you remember this? So here a and phi going to be changed, but the frequency omega will remain same. Output, the steady state output will become 0. It means the a will be only responsible to make it 0. And do you know what is a? A is nothing but the transfer function ys upon x of s mod of s equal to, you need to put first of all j omega in the magnitude. So when you will put j omega here, you will get actually j omega whole square plus 4 upon, you will also open it, so s square plus 2s plus 1. So here also you can put s equal to j omega. So you will get minus omega square plus 4 upon minus omega square plus 4j omega plus 1. Now you need to make sure that, sir, if I will take the magnitude of this part, if I will take the magnitude of transfer function yj omega and xj omega, can tell me bacha, if you will take the magnitude, what you will get? Right now it is not right. If I will take the magnitude here yj omega upon xj omega, then the real part is same only. So minus omega square plus 4 as it is, and here under root of real part and imaginary part. Real part is what? 1 minus omega square ka whole square plus imaginary part matlab 4 whole square. Now student, you need to make this term equal to 0, because this will only give you a, and a will become 0. Why? Because you have to make yt 0. Because you have to make yt 0, examiner is asking for the value of omega for which the steady state value of output 0. It means if you want to make output yt 0, you have to make capital A 0, and to make capital A 0, the magnitude part should be 0. Here the magnitude part will be only 0 if omega will be placed as 2. So you will, when you will make this term equal to 0, you will get minus omega square equal to 4. So from here you will get omega 2 radian per second. Omega never negative. You cannot say that omega is minus 2. No, omega always positive. So frequency always positive. So correct answer for this question is 2 radian per second. How many of you guys getting the same? Do reply fast. How many of you guys getting the same? Please do reply fast. Correct answer option number. You had an option or numerical entry question. I think it is numerical entry. So it was a 2 marks question, guys. It is a gifted question, and those who like mathematics can easily solve this. Those who attended my control system lectures, you can easily solve it. You can just follow for control signal digital. You can follow the Ankur sir, and you can easily secure full out of full marks in control signal digital subjects, guys. Do reply fast and just share it to maximum, guys. Share it to maximum. Now I am again solving the next question. One more question I am having, guys. And the question is, you have to find out the impulse response for the signals and system question. And the question is, the differential equation is given, that is dyt upon dt plus 3yt dyt upon dt plus 3yt is equal to 3xt. dyt upon dt plus 3yt equal to 3xt. Find the impulse response, guys. Find the impulse response. Examiner is asking for, however, some theoretical part also can be there, but here I am writing just the given data. Find impulse response that was given in the question. Okay. So here initial value also I think it is given 0 only, and options are also given in the question. Options are also given in the question, guys. What are the options given? Twice e की power minus 2t. Option number B, twice e की power minus 3t. Option number C, twice e की power minus 3t into ut. And option number D, 1 by 3 e की power minus 2t into ut. Okay. So first of all, student, always remember when you will take the Laplace transform both sides, you will get here sys plus 3ys equal to 3 of x of s. The question data again we need to check, guys. Yes, it is 2x. Actually, it is 2xt. It is not 3. It is 2xt. Yeah. So it is a 2xt data. It is a data given data in the question 2xt only. Okay. It is 2xt, guys. It is 2xt. Okay. So it will be 2x of s, na? 2x of s. Yes, sir. Now when you will take the Laplace transform, first of all you have to take common in y of s in the left hand side. So inside the bracket you will get s plus 3, and here you will get 2x of s. Because examiner is asking for the impulse response, first of all you need to find out the transfer function. So ys upon x of s will be twice upon s plus 3. Because of impulse response, do you know the impulse response xt is nothing but the del t. So what about the x of s? 1 only. So examiner is asking for impulse response, it means ys will be twice upon s plus 3 only, and you have to take the inverse Laplace. And when you will take the inverse Laplace, you will get the yt value is nothing but twice into e to the power minus 3t into ut. Ut must be there, my dear student, because if ut will not there now, s plus 3 pole, this pole will be only stable if this pole s plus 3 is only stable if the system is causal. If the system is causal, then only this system is this is bounded. S plus 3 is bounded because pole line LHS, pole line the LHS will only bounded, will only stable if it is causal. And to make it causal, it should be multiplied with ut. To make it causal, it should be multiplied with ut. So definitely correct answer option number C for Chennai Super King. Correct answer is CSK, guys. Tell me yes or no. Option number B is wrong. Option number B is wrong. All the wrong. Option number C for Chennai is correct. Yes. Now I think, student, I am coming with more questions. So or other faculty members I would like to invite. Okay. First of all, my dear student, you all need to make sure that you have already shared the session, so that we also have a motivation to give you the live solution, and we will have a detailed discussion on the complete exam solution as well as the paper analysis. Yes or no? Okay. So my dear student, first of all, tell me, how was the paper? I have seen right now 2 questions, one from control, one from signals we have already solved. And I think before that network question also we have covered here. And many other questions we are also about to solve very soon. Just stay tuned on the YouTube channel, guys. Yes. So after that, I think some mathematics and aptitude questions also we are going to provide you very soon. Yes.
So, hello students, okay. NIT questions are hard, okay. Yeah. So yes, many of students are saying same thing, guys. Okay. So it's a hard question, or we can say difficult paper was there. So it's okay. Yeah. So I'm just here with another question, guys, of network theory, and it is again very moderate question actually. Okay. And the question is here. Sorry. So the question is like it is given to you. Here we have a dependent source. We have given one dependent source which is connected, okay, which is connected with a resistor and in series with a capacitor, guys, okay. And Here it is given again one resistor and one inductor, guys. Okay, and we are having one current source also. So this is the current source. Now the value is given to you. So this is plus minus 4 times I of x, guys. Okay, and this value is given to you 10 ohm, and this is minus of j 10 ohm, guys. Okay, and if I'm talking about this, so this is 10 ohm and this is j 10 ohm, and this value is I, and this I is equal to sine of 100, sine of 1000t, sorry. So this is sine of 1000t. Okay, so this data is given to you. Now if I'm talking about the dependent current, so this is I of x. Okay, and here this is A terminal, let us suppose this is B terminal, and you have to calculate. So for the given circuit, what you have to find? You have to find VTH for t. T is equal to 5 millisecond, guys. 5 millisecond. Is it clear? So now this is the question, guys, and we have to find what, guys? We have to find voltage across this AB at t is equal to 5 millisecond, guys. Okay, so here this question is from steady state AC analysis, guys. Okay, and in the steady state AC analysis, the question is from what, guys? Thevenin theorems. Okay, so for Thevenin's theorem, what we have to calculate? We have to calculate this VTH, guys. So this is our VTH, yes or no? This is our VTH, and if this is our VTH, what we can write? So we can write KVL here, guys. Okay, so just write KVL. If I'm writing KVL here, so what is the value of KVL, sir? Just tell me, please. So the KVL is minus of VTH plus of what, sir? So this is 10 times I of x, and minus of j 10 I of x, and this is equal to 0. Okay, so from here what we can say, sir? We can write VTH is equal to, what is this? So this is 10 minus j 10 into I of x. So this is, let us suppose this is our first equation, guys. Let us suppose this is our first equation. So here if you want to write VTH value, so first of all we have to calculate this value of I of x, guys. Is it clear now? Okay, so how to calculate this value of I of x, sir? So again it's a very simple question, guys. Okay, so here if we convert this circuit, or we can say if we convert this value, if we convert this circuit actually in the what, guys? In the series connection, we can convert this current source in the voltage source, or we can simply apply source transformation here. So we can write what, guys? Directly KVL. Okay, now we can directly write KVL, guys. Is it clear, yes or no? So here what I'm writing, guys, directly I'm writing, it's a source transformation equivalent circuit. So here the circuit is, this is our dependent source of the value plus minus 4ix, and here it will be in the series with this value. Okay, and here this will be converted into voltage, and this is connected with a resistance in series with a capacitor, guys. Is it clear, yes or no? Is it clear, yes or no? So just write the value, guys. So this is 10 ohm, this value is minus of j 10 ohm. Okay, and this value is given to you, which is 4 times I of x, and this is given to you 10 ohm, and this is j 10 ohm, and this value will be out, guys. So as if this is voltage, voltage is equal to what, guys? I into z. Okay, so what we can write, actually this I is nothing but one angle of 0 degree, guys. Okay, and this value is what, guys? So let us suppose this is z, so z is equal to 10 plus j 10. So what we can write? We can write this is 10 root 2, and the angle is how much, sir? So angle is 45 degree. Is it clear, yes or no? So what we have to calculate? So voltage is equal to I into R, I into Z, we can say. So this will be 10 root 2, and the angle is 45 degree, guys. 45 degree. Now it's very simple circuit. Now it's very simple circuit, because this current is I of x, and here this is VTH, guys. Now if you can write KVL in this mesh, then easily we can find the value of Ix, and by the getting the value of Ix, we can put the value of Ix here, you will get the value of VTH, guys. Is it clear, yes or no? Is it clear, yes or no? Just tell me, please. Okay, now sorry. Now just write the value, guys. So here what I am writing, so this is plus, this is minus, so this is minus of 10 root 2, 10 root 2, and the angle is 45 degree, guys, plus this is j10 I of x plus of 10 I of x, and this is minus of 4 ix, and this is plus of 10 I of x, and this is minus of j10 I of x, and this is equal to 0. Is it clear, yes or no? Just tell me please. Is it clear, yes or no? Just tell me please. Okay. Now if it is clear, what we can say here, guys, so here j10 ix and minus j10 ix is cancel out, and this is equal to 10 plus 10, 20 minus of 4, so this is 16 ix. So we can write 16 times I of x is equal to, this is 10 root 2, and the angle is 45 degree, guys. Is it clear, yes or no? Just tell me please. Is it clear? Yes. Okay. Now, so from here, write the value of I of x. So we can write, therefore, I of x is equal to how much? So this is equal to 10 root 2. So this is 10 root 2, and the angle is 45 degree, and this divided by 16, guys, and this divided by 16. So this is the value of I of x, guys. Okay. So from the equation 1 and equation 2, we can easily find the value of what, guys? VTH. Okay. So as we have the value of VTH is how much, guys? So this is 10 minus j10 into I of x. So here I am writing, so therefore we can write VTH is equal to j, or we can write what, guys? So this is 10 minus j10. So this is 10 minus of j10 into I of x. Is it clear, yes or no? Just tell me please. Okay. Is it clear, guys? Fatafat respond please. Okay, respond, guys. How many of you got the correct answer? How many of you got the any answer? Just respond here. Okay now. So here what we can write, guys, so just we have to convert this rectangular into polar form, because we have in the polar form. So we can write, this is 10 root 2 with the angle how much, guys? So this is 1 minus j, so this will be minus of 45 degrees, minus of 45 degree. So this is the value of this, and here I of x we have to multiply. So this is 10 into root 2, and this divided by how much, sir? So this is multiplied by this value with the angle 45 degree, with the angle 45 degree. Is it clear? Is it clear? So just calculate this value, guys. If you calculate this value, you will get the answer. Okay now. But what we have to remember, we have to calculate this value at what, guys? So it is given to you, we have to calculate this value at 5 millisecond, guys. Just we need to careful, very careful about this point, guys. Is it okay? Otherwise, many of student is doing what? Directly getting this value and putting the answer, guys. It is very wrong. It is totally wrong, guys. Because what we have to calculate, always we have to remember that point, guys. We have to very careful about the given data. Okay now. So here what we can write, guys, so just see, we can calculate this like what, guys? So here we can write, this is 10 root 2 into root 2. So again this is 10. So this root 2 into root 2. So it will be 2, sir, and this divided by 16. This divided by 16, and this angle is 45 and minus 45. So this will be 0 degree, guys. So we have the value which is equal to 8. So we can write, this is 2. So 100. So this is 25. We can write, this is 12.5 angle 0 degree, guys. Okay, and this is our VT. But at a time dependency, if I'm talking about time dependency, so here this is given in sine 1000 t. So we can write here, this can be written as 12.5 into sine of 1000 t, sir. And this is the value of VT, or you can write the VTH value. You can write, this is VTH value actually. This is VTH value. So we can write now at a t is equal to 5 millisecond. What we can write, guys? We can write this value of VTH, and this is equal to 12.5 into sine of, so this is 1000 into 5 into 10 to the power minus 3, guys. Is it clear, yes or no? Okay. So when you will calculate this, you will get cancel out. So just write this value, guys. Just write this value only. Okay. So from here, when you will calculate this, you will get, this is approximately minus 11.98 volts, guys. You will get this value. You will get this value. Is it okay? Is it okay, guys? Okay. So here, if I'm talking about the network theory, so from till now we have discussed three questions from network theory, guys, and all the questions are very moderate, guys. Okay, we can't say it is difficult questions. So if I'm talking about network theory question, what we have discussed yet is very moderate, guys. Okay, so we'll discuss more problem. Okay, so now Priyanka ma'am is coming to you with you. Okay, and she will discuss mathematics and aptitude with you. Okay, so just we continue, guys. Okay, and we will come one by one with the questions, guys, with the perfect data. Okay, how actually we are just getting the questions and coming with you. Okay, with the clarity, guys, with the no, without any confusions. Okay, now, yeah, exactly, very good. Okay, so here Priyanka ma'am is coming with you with the mathematics and aptitude. So we continue, guys. Okay, thank you, guys. Okay, so just wait for 1 minute, sir. Yeah, so just wait for 1 minute. Ma'am is just connecting. Okay, so she will.
Hello everyone, welcome to all of you. So, as now I'm having few questions of engineering mathematics and general aptitude of electrical branch. So guys, let's start with the questions from general aptitude first. So let's start with the very first question. Okay, as we were expecting the question from the unit digit concept, so here we are having the question, basic question of unit digit. So the question is unit place. This question was the 2 marks question and the MCQ. Okay, the question is unit place of, we need to identify the unit place of 3 to the power 999 multiply with 7 to the power 1000. Okay, and options were also there for you: 1, 7, 9 or 3. These are the options. So let's approach it. As we know very well, we have to identify the unit digit here, so we will use the cyclicity concept. The cyclicity of 3 is 4 and the cyclicity of 7 is also 4. So what we will do, we just divide the last two digits with the 4. Okay, whatever be the remainder, if I will divide, the remainder will be 3. Whatever be the remainder, so that will be the, actually the question is not asking me about the unit digit of 3 to the power 999. Now the question is asking me to the 3 power that remainder. So this is the 3 power that remainder 3. Okay, and when we talk about here, the same concept we will follow for the 7 power something also, because the cyclicity of 7 is also 4, dear students. So when we will approach it, here we are having 0 0, so we will not use 7 power 0. Okay, we can go directly also, so it will be nothing but the 7 power 4. Okay, we will approach it 7 power 4 and the unit digit will be 1. So we can approach like 3 power 3 multiply with 7 power 1. So it will not 7 power 4. So it will give me the 7 multiply with the 1. So my final result will be 7. My final result will be 7. Yes? Is it clear? My final result will be 7. I hope this is clear to everyone. Okay, very good. Now let's go with the next question of general aptitude. I'm having more questions of general aptitude. So the next question is the counting figure. So let me write down the question, and this question was a MSQ. I'm going to write down the question here for you. The next question, okay, not MSQ, this is MCQ, okay, and 1 mark question MCQ. It is asking about how many triangles. It is asking about how many triangles we are having in the figure. The figure is given to us. The figure looks like this. The figure looks like this. We are having 1, 2, then 1, 2, 3, 4. Okay, so this is the figure we are having, and we have to count how many triangles are there. Yeah, and the options are also there. Let me write down the options: 20, 24, 18 and 12. So we can identify very easily. Okay, with the trick of the triangles we can solve this question even without counting the actual triangle. So we can solve. First of all, let's make the outer triangle. So what I'm going to make here one outer triangle for you. We can see we are having one triangle, this, which I made from the yellow color. So you can see in this one we are having 1, 2, 3 and 4 small triangles, right? So we can solve these type of questions directly with the simple trick. Here you are having first option that you can count. Even you want, then you can give the naming also A, B, C, D. Then you can count one triangle is A, B, D. Second is A, B, C. Then we are having A, D, C. Then we are having B, C, D. So in this way you can count. Second way we can approach, and here also you can make something O and then you can count. So rather counting 4 and 4, 8 triangle, we can directly write down. We are having here 4 triangles. We can write down the small triangles 1, 2, 3, 4. 4 multiply with the 2 because the base are 2. So 4, the diagonals are 2. So we can write down 4 2 ja 8. So 8 triangles we can count in this figure. 8 triangles we can count in this figure. When we go for the outer one, let's approach the outer one. So for the outer one, let me use the green color. So it will be visible to you. So this green color, I hope this green color will be shown to you. Yes, okay, now it is visible. So we can count from here. We can take one another. Okay, this also. So from here now, here also we can go with the concept wise. Rather counting the figures, we can go directly with the concept wise. Okay, we can use the tricks here. So how we can approach, beta? So I am going to tell you about this one. Whenever we are having a triangle like this one, and suppose from the vertex of this triangle, if I just draw some lines and I need to count triangles in this figure also, then I have to write down the counting 1 2 3 4. Then I have to add it 1 plus 2 plus 3 plus 4. So this is 10. So we can count in this figure 10 triangles are here. The same concept we learned in the classroom also. The same thing we can approach here. So from here we can see in this corner I'm having one line. Okay, you can see one line from this to the opposite side. So here we can count 1 and 2 triangle. Same way we can go with this corner also. Here I am having also one line. So these are 1 and 2 triangles. Same way we can approach with here, that is also 1 and 2. Same way we can approach with here, that is also 1 and 2, right? So I can go with 1 plus 2, 3 triangles here, 3 triangles here, 3 triangles here and 3 triangles here. So once I had 8 plus 3 4 ja 12. So 12 plus 8 will be 20, my answer. So we can easily approach that. The result is here in this figure. Internal we are having 4 into 3 12. 12 plus 8 20 will be my final answer. So I can write down the final answer as 12 plus 8 20, which we can see in the options, available options. So in this figure, in this given figure, we are having total 20 triangles. Dear students, we are having total 20 triangles. Now there is one question from geometry also. Let's approach that question also. The weightage of that question was 2 marks. Let's approach that question. So I'm going to write down here the question for you. That was a 2 mark question and MCQ. let's approach it. So the question was, okay, the question was a square with sides, a square with sides of length 6 centimeter is given. Side of a square with sides of length 6 centimeter is given. Okay, the boundary of the shaded region, I will draw the diagram also and then I will explain it in a very simple manner. So the boundary of the shaded region, boundary of the shaded region is defined by the two semicircles whose diameters are the sides of the square, sides of the squares. Okay, so as shown in the figure, we need to find out the area of the shaded region. So I am going to draw the given diagram here, then I will solve the question on the other side. Next slide. 6 centimeter, we are having this one semicircle, it is given, another semicircle is given to us. Okay, as we are having there the 3 centimeter, the side is total 6, so the radius will be surely 3. Okay, now let's approach this question. If any of you approach the question, you can tell me the answer also. Okay, this is the MCQ, but I don't have the options for this one. I don't know about whether it is a MCQ or NAT, I am not sure. Okay, but I don't have options for this question. Let's approach the question, we can approach it directly. So now let's solve this one. Okay, square, I think this is an NAT, I am not sure, but the weightage is clear that the question is of the 2 marks. So let's solve the question. I have to draw the diagram here again for you, then everything will be clear to you. So here we need to draw a square of 6 centimeter side. Yeah, this is the square of 6 centimeter side. Beta, the same pattern of question which I am going to solve now, the same pattern of question has been asked in the GATE 2021. Exactly the same pattern of question I will show you. Right now NAT it was. Okay, yeah, very good. So it was NAT. So we can see that same pattern of question has been asked in the GATE 2021. I'm going to show you how to approach the question. So we are having 6 centimeter here. As it is given to us, we have to make a semicircle here. So this is the semicircle. In the same way we can draw one semicircle. So when it is a semicircle, or if I am having a side of a square as 6 centimeter, then the radius of this one will be half, means this will surely cut at here only. So the radius will be 3 centimeter for upper semicircle. For dash dash dash, this one also this semicircle is also having the radius 3 centimeter. Yeah, okay, 9 pi, 6 pi, 18, 20. Prakash Chaudhary is what this was with the options. Is it? Are you sure? Right now I don't have the options. We can solve it. Okay, let's solve it. So if I will tell the complete answer so that you can identify your answer also. So here we are having the thing. So this, in the same way, this side will be also 3 centimeter. This side will be also 3 centimeter. So from this figure, I need to identify the area now. So from this figure, I will just approach something. I will just approach something from here. So I can just draw a circle. Okay. So in this way, I can just approach it. Okay. And here I need to identify the area. So in this way, we can solve it. 12.87. No, it is 5.13. Okay, let's approach it. So here we are having, first of all, just have a look. We are having this side as in 3 centimeter, this also 3 centimeter. Okay, as I can show, I can see beta ki if I will just make a semicircle from here, means a circle, if a circle is a total fourth, okay, if I want to find out the 1/4 portion of a circle, it looks like wait a minute, yeah, okay, so it looks like here this is the 1/4 of a circle, so I can see this portion is 1/4 of the circle. So from here I'm going to make the 1/4 of the circle. You can see with the, let me draw this diagram again, so it will be showing here only. So if I will show you, yeah, this one, so you can see beta right now this one looks like the semicircle, okay, this one looks like the semicircle, huh? So we are having the 1/4 portion of the semicircle, we are having the 1/4. Yes, so give me 1 minute. Okay, I think the datas are not clear. Let me check it out. Okay, we will come to this question again. Till that, we are having more questions from the aptitude also. Just hold it here. We are holding this question here only. We will come to this again, as I am not sure right now about the questions data, because okay, let's hold it. 20 is the answer. Okay, we will come to this again. Okay, we will come to this again. Now I'm having more questions from the aptitude. We can come to the more questions. The one question is from the English. That the question was permit. The next is blank. This was enforce. The next is relax. Okay, let's approach here. So we can see the relation enforce and relax. Enforce means to force someone. Okay, relax is the relax only. Enforce is to force someone. Okay, to make compulsion. That is the enforce. So we can see the relation between enforce and relax is the opposite. We can see the relation between enforce and relax is the opposites only. Okay, so we have to opposite means antonyms only. So we have to identify here also the relation. We are having options also in this one. The options are reinforced. Next one is allow. The next one is license. And the last one is forbid. So we know very well we have to identify the opposite of this permit. So the opposite will be surely forbid only. The opposite will be surely forbid only. For permit, we can go with the opposite, that is the permit. Opposite of permit. Beta, I am not sure. Aditi and Gautam, I am not sure about the data. Actually, now in my phone it is not clearly visible. So that's why I am just holding this question. I will come to that question again. Just don't worry. Okay. Till that we can see more questions. Okay. Now, so the permit and the opposite of this one is forbid. So the answer will be forbid. Now we are having few questions of engineering mathematics also. Let's approach the questions from engineering mathematics. So first of all, one question is in probability, that is asked in the general aptitude segment. Let me write down that question. That is a very simple question of, yeah, that was the 1 mark question. Okay, in aptitude we are having, the question is given a fair dice, okay, fair 6-faced dice or 6-sided dice. It is given to us where the faces are labeled as 1, 2, 3, 4, 6. Where the faces are labeled as 1, 2, 3, 4. Okay, 1, 2, 3, 4. 5 and 6. So this is a fair dice, and in that one, what is the probability? This is the very simple question of what is the probability of getting 1 on the first roll of the dice and 4 on the second roll of the dice. Okay, let's approach it. So we are having options also. This is a simple question. We can approach it directly. 5 by 6, 1 by 6. Next is 1 by 36, and the last one is 1 by 3. As we know very well, here we are having the okay, 20 or 6 pi. I will check. I will confirm that one. Just hold on. Don't worry, beta. Okay, I will come to that question again. Okay, right now just focus here. So we are having a 1 mark question from aptitude also. This question was written in the aptitude, and the question is of probability. So we know very well it is asking about a fair dice. So we know in a fair dice all the outcomes will be 1, 2, 3, 4, 5, 6. All the outcomes will be equally likely and equal probable. You are asking about 1 on the first dice, first roll, and 4 on the second roll. So both the rolls are independent. From here you can approach this question in the 2 way. Suppose you want, then you can write down the total sample space like this also. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, if you think कि मुझे ऐसा करना है, then this one is for first dice, this one is for the second dice. Similarly, you can approach and so on and so on and so on. 6, 1 and so on, 6, 6. You can approach like this also. In this case, in this method, you can directly see the only one case is there in which on one dice 1 is there, and on the second roll 4 is there. So this is the only favorable case. This is the only favorable case. We can write down the required probability directly as 1 total number of outcome in throwing 2 dice will be 6 power 2, that is 36. So we can approach the answer as 1 by 36 also. If you think nahi mujhe itna lamba method nahi karna hai, then we can approach to another one also, that is very simple, and both the events we can see here are independent. So there is no relation between first event and the second event. So we can write down directly the required probability, that probability getting 1 on the first dice and probability getting 4 on the second dice. This will be my answer. Getting 1 on the one dice will be 1 by 6. Getting 4 on the second dice will be again 1 by 6, because 1, 2, 3, 4, 5, 6 all events are equal probable and equally likely. So the result will be 1 by 36. So in both the manners you can approach, but with both the ways the result will be 1 by 36 only. This was a MSQ, so we can expect the result as option C only. Okay, so this is the final answer of the question. Now I am having more questions from engineering mathematics also. So let me write down the question of engineering mathematics. One question is there in the form of the, okay, there the question. Let me write down the question for you. For a given vector, okay, we think that this question is, we are having 2 superb questions from the differential, in the engineering mathematics, and both the questions are from the calculus. So look at here the question. For a given vectors W, for the given vector W equals to 1, 2, 3 transpose. This is the vector which is given to me. Okay, the vector normal to the plane. The vector normal to the plane by W transpose X equals to 1 is, we need to identify the vector which is normal to the plane W transpose X, okay, equals to 1. So we can easily solve this question. First of all, let me write down the options also. We are having the options as 3, 2, 1 transpose. Second one is 1, 2, 3 transpose. The third one is -2 and 2 transpose. And the last option I am having as 3, 0 or minus 1 transpose. Okay, this was a 1 mark question. This was a 1 mark question. So this is an MCQ. Okay, we are having. So we can approach the question very easily, as here now. First of all, I can see whatever it is asking, we can start from here only. It is asking about W transpose. So the W transpose will be 1, 2, 3. Okay, X will be X, Y, Z only. So we can write down like this, X, Y, Z is equals to 1. When I will multiply, I can make a vector. Actually, this question है calculus का, but it looks like this is a question from algebra. There is a twist, so they just match, they just merge two topics together, algebra and calculus. So we can see this is the question basically from the calculus only, but they just formed it in the form of vectors. So we think that the question algebra ka hai. So when we will multiply, it will give us x plus 2y plus 3z, and here it is equals to 1. Yeah, we are having. So if I will just see this one, I am having that this is a scalar function, and this in front of the scalar, suppose this is my scalar function phi. Okay, and in front of this I am having a constant c. So this is the question now of vector calculus, phi equals to c, and you are asking about the vector normal to the plane. So vector normal to the plane is nothing but the gradient only. So actually they are asking about the gradient. They are asking about the gradient only. The gradient of phi will be my answer. So I can easily approach the gradient of this one. If I will go with the function as an x plus 2y plus 3z is equals to 1, I can find out the gradient of this one, as you are asking about the unit vector normal to the surface. So that is nothing but the gradient of phi. So gradient of phi will be, how we can find out the gradient? I del phi by del x, j del phi by del y, and k del phi by del z is the gradient only. So I have to do the partial differentiation of this complete phi with respect to x. It will give me 1 only. So it is nothing but I, plus with respect to y it will be 2j, with respect to k it will be nothing but 3k. So I'm having the vectors as an I plus 2j plus 3k. Why did they give questions from microcontroller? Okay, so we are having x, the vector as an I plus 2j plus 3k. If I want to write down the given vector, or just the vector we are having in the form of the matrix, so I can write down the result as it is nothing but 1, 2, 3 transpose. So this will be my answer, which I can see here in the option B for Bombay. 1, 2, 3 transpose will be my answer. Okay, I hope we can see the result very easily. So this is a very good question, although the weightage is 1 mark, but yeah, we can approach the question very easily. Okay, I'm having one more question of the same concept. Okay, that is asking about again the gradient, but in a different manner. That means as I can see that two questions are from the vector calculus and both are from the gradient only. So we can see one more question. Let me write down that question also. I'm having, yeah, this is the question in the function way. Okay, this is written to us. Let me approach to the solution for that question also. The question is a quadratic function of two variables is given to us. A quadratic function of two variable is given as function of x1 and x2, and the functions are x1 square plus 2x1 x2 plus 3x1 3x2 plus x1 x2 wait a minute, x1 square plus 2x2 square. Okay, x1 square plus 2x2 square, 3x1 plus 3x2 plus x1 x2 plus 1. Okay, now it is asking about the magnitude. It is asking about the magnitude of the maximum rate of change of function at the point 1 1. At the point 1 1. So basically they are asking about, how do you approach this question, guys? Had you approached this question? So basically they are asking about the, yeah, okay, they are asking about the gradient only. So the magnitude of gradient. So we can write down the magnitude, the magnitude of gradient of the given function at the point 1, 1, 1. So it is asking about this one only. They are asking about this thing. So let's approach the question. Yeah, the answer was 10. Who's that? Very good. Very good. The answer is 10. Surely we can approach. So how we can approach? Let me write down the given function we are having as x1 square, 2x2 square, 3x1, 3x2, x1, x2 plus 1. I think this is the function we are having. Yeah, exactly. So now we can approach here. Let me confirm also. Yeah, this is the function we are having only. So from here we can find out the gradient of f, which will be I into del f by del x and j into del f by del y only. Means I can write down x1 and it will be x2. So it will be 2, we are having I, so it will be 2x1 plus 3 plus x2. Okay, when we go for the j, it will be 4x2 plus 3 plus x1. We are having the point as 1, 1 also. So now we can put the values of x1 and x2 as 1, 1 here. So when we will approach it, it will be 2 plus 3 plus 1, 5 plus 1, 6 plus j we are having as an 4 plus 3 plus 1. So 7 plus 1, 8. So we can go with the 6i plus 8j. We need to find out the magnitude of this one. We can easily find out the magnitude. Okay, that is nothing but the square root only. So that will be 6 square plus 8 square. So 6 square is 36, 8 square is 64. When we will solve it, it will be 100, root of 100. The result is 10 only. So we can approach the result as 10. Yeah, very good. So that's why the result is 10. So this was an NAT. So we can write down the answer as in 10 for this question. And the weightage of this question was 1 mark, I think. I don't have the weightage right now, but I hope the question is clear to everyone. Okay, guys. So I will search more questions for you. Okay, once I am having the confirmed data, then only I will approach the more questions. So let me give some time. Let me try for the more questions for you. Let me search and then I will back again with the more solutions. Okay, guys. Till that, stay tuned to our this channel only. So that the remaining faculties are waiting for their respective subject. So just hold on here.
Hello dear students, welcome back. So I think engineering maths aptitude questions you have seen. Now student, we are ready with the complete analysis for GATE 2023 EE. So how many number of questions has been asked from a particular subject, I am going to tell you here. So first of all, general aptitude as expected 15 marks, engineering mathematics as expected 13 marks, but this time engineering mathematics 11 marks only asked, my dear student. So generally we always tell in the classes that 28 marks are secure for engineering maths and aptitude, but this time for EE, engineering mathematics is 11 marks as well as general aptitude 15. It means non-technical part is almost 26 marks. Okay. Power system has weightage of 11 marks. Power electronics has a weightage of 6 marks. Control system as expected minimum 9 to 10 marks question generally asked. So control system scoring subject. Rahul, for you I scored 70 plus marks. Very good, Rahul. This is a very good score because question paper is not easy and it's moderate to tough question. So cutoff maybe not very much high. So you will get a good rank when you will if you have scored 70 plus, then definitely you can expect a very good rank, my dear student. Yes. If I talk about network theory, 8 marks question as expected. Signals and system, surprisingly 12 marks question. Generally for EE, signal and system weightage is 10 to 11 maximum. 10 maximum or 11 maximum, but this time it reached to 12 marks. That is very good news, guys, because signal system, control system, numerical subject, and procedure based questions are there. If you like mathematics, you can definitely score full out of full marks in these subjects. EMFT for double E, as we all know that weightage is very less, so as expected 5 marks only weightage. Electrical machine core subject 11 marks weightage as expected. Measurement only 2 marks question has been asked. For analog electronics 6 marks question has been asked. For digital circuit 4 marks question. So this is all about the complete analysis of 100 marks with respect to the different subjects in the electrical syllabus. Okay, guys. Now I have a following questions of, I have some questions for control system and signal system. We will solve one by one, and we'll have a questions of digital electronics also, guys. So stay tuned on the YouTube channel and just share it to maximum, guys, so that other students will also get benefit. Whether you are from north or south, everywhere you need to spread this information that IMS Get Academy is going to solve all the detailed solution of live in a live manner of EE 2023 GATE exam that was conducted today only at 9:30 to 12:30. Okay, and MCQ 40, NAT 20, MSQ 5, as I already told you earlier. Now I have one question here. So I am just giving you the data that was given in the question. So what is the data, guys? Find fundamental time period for this. Find fundamental time period. Find fundamental time period. I am writing in small form. Fundamental time period for. Find fundamental time period for x of n. And what is x of n given, guys? X of n given as a given 1 plus 3. X of n as a given. Okay, so last tip I can make white. So here is 1. X of n is what, guys? 1 plus 3. 1 plus 3 into sine of, this is a very easy question actually. 1 plus sine 15 pi upon 8n plus 3 pi by 4 whole bracket close minus 5 into sine of pi by 3 into n minus pi by 4. So this is the only question, guys, an examiner asking for the fundamental time period. As you all know that addition of DC term does not affect the periodicity of signals. It means, tell me beta Rahul, tell me beta, write for you what is the answer for this. If you have appeared for this, tell me. If you have attempted for this question, tell me what is the answer. So n1, do you know n1 how to find out? N1 upon 2 pi upon omega 0 matlab n ka multiple. So you should write here 15 pi upon 8 into small m. So pi get cancelled out. So ultimately what you will get, 8 to just 16 upon 15 into m. So this is also get cancelled out. So answer will be what, guys? 16. Similarly, what you will get as a n2, you will get as a n2 2 pi upon omega 0 into m. What is omega 0? Omega 0 equal to pi by 3. Omega 0 matlab pi by 3 into small m. So pi again get cancelled out, guys. So what you will get? Pi again get cancelled out. So 3 to ja 6. Here is 6 by 1 into m. So again you are looking for the minimum number of integers. So 16 and 6. And do you know what is fundamental time? The fundamental time will be n is nothing but LCM of n1 and n2. LCM of n1 and n2. So if I talk about LCM, then what you will get as a LCM, guys? You will get as a LCM 16 or 6. Now don't do mistake in LCM, guys. If you want to find out the LCM of this, you need to just make a table. You just need to say the table of 16 to the 32. Whether 32 is perfectly divisible by 6 or 16, no. Then go for next 48. Yes, 48 is it's just equally, we can say that, divisible by 16 as well as 6 also. So correct answer for this question is 48 only. So the fundamental time period for this given question is 48. Correct answer for this question, guys, 48. How many of you got the answer? Just let me know. How many of you got the answer 48? Just let me know, guys. Just share it to maximum, guys. Correct answer for this question is 48. It is a GATE 23 EE. It is a GATE 23 EE question, and it is a very easy question. It is a very easy question, I must say. Yes. Now I am having a next question also from control system. And what is the question given, guys? This question given, we have a closed loop system is given in the question, that is plus minus, and here the value is given, that is g of s. Here the value is given, that is g of s, and here one value is given, that is h of s. That is h of s. Okay. And here what we are having, guys? Here we are having r of s. Here we are having c of s. That is given in the question. And it is also given in the question that find out what is the exact language of the question. It is also given that you have to see the entire right hand side S2 limit. I hope you remember the Nyquist plot. So one is S1, this one is what? If I talk about this one is S1. But this time examiner is asking for the entire right hand side region, and limit r goes to what, guys? Infinity. So actually examiner is asking for the point. Examiner is asking for the given point S2, which will be dedicated for the S2 step when the contour goes to from r tends to from infinity, from here if I would talk about the angle, then pi by 2 angle to minus pi by 2 angle, and the magnitude goes to infinity. How many of you remember how to make step S2? How to map step S2 to you? Do you know in the polar plot S1 is nothing but the polar plot? How many of you remember S2? To S2 we need to put, sir, to map S1 we have to make polar plot, that you know very well. From how to do a mapping from S plane to GS plane, I am telling. S2 के लिए क्या करते हैं, sir? We have to put limit r tends to infinity, r e to the power j theta, where theta vary from plus pi by 2 to minus pi by 2. However, here theta is not required because the GSHS value that is given in the question, this was GSHS value that is given in the question, it was 3s plus 5 upon s minus 1. It was 3s plus 5 upon s minus 1. So this was the given value of GSHS, guys, and you are supposed to find out that particular point for which we are having the contour from infinity radius and the positive half the contour. Okay, so what you need to do, you need to put here but you need to put equal to r equal to infinity, sir, and wherever is s you need to put what, guys? R e ki power j theta. So 3r e ki power j theta plus 5 upon, here is also r e ki power j theta minus 1. But now, student, when you will put r tends to infinity, so this term is approaching to infinity. It means infinity plus 5 is nothing but infinity. So you can easily neglect this 5 and 1. So what you will get ultimately now, 3r e to the power j theta upon r e to the power j theta, and where you can say that the limit r goes to infinity, sir. Now tell me, my dear student, this term and this term is very, very high, but cancel out only. So correct answer is what? 3. It means if you will map from the S plane to GSHS plane, then in the GSHS plane if I will make, then this is my real part of GSHS and this is my imaginary part of GSHS. Then you will get a point. That point will be 3 and 0 only. So that is why correct answer option number D, whatever the question we have given in which it is mentioned in the option number D for Delhi. So point is 3. Sir, break de do, भूख लगी है. Okay बेटा, okay. So if you have, अगर आपको ब्रेक चाहिए तो आप फटाफट से खाना खा के आ जाइए, और ये YouTube वीडियो है, अगर आप कुछ मिस करते हो तो बैक जाके भी कर सकते हो. नो हाँ. So dear student, we have one more questions. Okay, हमारे पास अभी और भी क्वेश्चंस हैं, फटाफट से चलिए बात करते हैं नेक्स्ट क्वेश्चन का. एक और शानदार क्वेश्चन आपके पास गिवन था जो कि सैम्पलिंग का था. आइए बात करते हैं नेक्स्ट क्वेश्चन जो कि सैम्पलिंग का है. बड़ा ही अच्छा क्वेश्चन है बच्चों. ये a continuous time signal xt is given. A continuous time signal xt. What is signal given, guys? Signal given is twice into cos of 180 pi t whole bracket close into cos of 60 pi t. The easiest question in my class. I have solved this type of question many times. Sampling theorem, guys. Okay, sir, very thank you. Okay. So now here, student, now a continuous time signal xt is given and sampling frequency also given, guys. Sampling frequency that is nothing but fs is given, my dear student, 200 hertz. Cutoff frequency of the low pass filter also given. I am just writing the data. The cutoff frequency of a low pass filter The cutoff frequency of a low pass, cutoff frequency of a low pass filter is 100. Cutoff frequency of a low pass filter is what, guys? 100 hertz. It is given in the question. It is given in the question 100 hertz, 100 hertz. Then examiner is asking for the maximum. Examiner what asking for? The maximum number of frequency, the maximum frequency present, the maximum frequency present at the output of samples, present at the output of sampled signal, output of sampled signal. So this is the roughly data. The given data is perfectly correct. The language I have just mentioned approximately, but the given data is this only. So tell me how to solve such type of question, guys. Whenever such type of question will come, first of all you have to find out the maximum FM value from the x of t, and we have to check the number of sample signal present at the output will be NFS plus minus FM, and in this formula you can start putting value of n equal to 0, 1, 2 and so on. Your first object in this question is what, guys? Your first object should be what? You need to write the question as it is. First of all, 2 cos of 180 pi t, 2 cos of 180 pi t dot cos of 60 pi t, 60 pi t. Now student, here 2 cos a cos b, 2 cos a cos b matlab cos a plus b plus cos a minus b. So you will get here cos a plus b, 180 plus 60. So you will get actually 240 pi t, yes or no? Cos a plus b plus cos a minus b, cos a minus b matlab 180 minus 60. So here 180 plus 60, 240, and 180 minus 60, it means here 60 pi t. Now student, here this is x of t, so you are looking for the maximum frequency FM. So FM is, this is omega m, this is also omega m, but which will give you maximum? Here you will get maximum now. So FM value you will get as a 120 hertz. FM value you will get as a 120 hertz. Is there any doubt, guys? No. Now here FM value is also given now, FS value is also given, cutoff frequency is also given. This is the cutoff frequency and FM also there. Now you can easily apply. Now you can easily apply, guys. So if I will apply NFS plus minus FM in the step number 1, in the first step I will put n equal to 0. If I will put n equal to 0, then I will get the formula plus minus FM only. And do you know what is plus minus FM? Do you know what is plus minus FM? FM value itself 120 hertz. FM value itself 120 hertz. So it is plus minus 120 hertz only. Plus minus 120 hertz only. Clear? If I talk about the second one, guys, n equal to 1, then if you will put n equal to 1, what you will get? You will get FS plus minus FM. And what is FS value? The sampling frequency that is given in the question was 200. Was 200? Yes, sir, 200. Plus minus FM matlab 120. So when you will do this, 200 minus 120, you will get 80 hertz, as well as when you will add this, you will get 320 hertz. Similarly, if I talk about the third one is not required, but still if you want to check, then n equal to 2, the formula will become, sir, 2FS, the formula will become 2FS plus minus FM. So when you will do this twice into FS, what is FS? FS is 200 now. FS is what? 200, sir. So when you will multiply with 2 into FS, it will be 400, sir. 400 plus minus 120. So you will get exactly 280 and 520. But why it is not required, sir? Because the cutoff frequency of the low pass filter is very less. It is 100 hertz only. It is given in the question, guys. It is given in the question. So cutoff frequency will block all the above frequency, which is all the frequencies which is above 100 hertz. So out of this is also going to be blocked. This is also going to be blocked. This is also blocked. This is also blocked. Only one frequency going to be passed. So the answer, what, guys? So answer for this question is 80 hertz only. For this question, particular question, correct answer is 80 hertz. How many of you got the answer, guys? Tell me. How many of you got the answer? Tell me. 80 hertz. How many of you guys got the answer? Tell me. So correct answer for this question is 80 hertz only, guys. Yes or no? Yes. Chalo. Now I am having one more question to you guys, that is from control system. It's very easy question. You have to find transfer function from ys upon r of s. And here option elimination you guys can do. In my classes I always tell you, always go for option elimination if there is any scope. So here this is the diagram. Here we have a little bit different diagram, but don't confuse here. 2, 3. Here we are having again summation. Here we are having again summation, just like this. Okay, this is also a loop. This is also 1 by s. This is also 1 by s. and here also we have a positive loop. This signal is coming to like this, and after that here we are having I think one only. Here it is connected to like this. ये तो question है, यही question. Now tell me guys, here what we are having y of s, and here what I given r of s. Now tell me, options are given there. Options are given. I will give you options. So by observing the option now, in this question there is an option of there is opportunity for option elimination. 3s plus 2. Option number B will be 3s plus 2 by s plus 1. Option number C will be 3s plus 2 by upon s minus 1, and option number D will be 2s plus 3 upon s plus 1. Now student, how to solve such type of question? First of all, you need to tell, sir, what will be the forward path? If you talk about the forward path, how many forward path possible for this question? The forward path matlab how many ways to reach to output from the input. It means RS से YS पे जाने के कितने रास्ते हैं यार? So first of all, here you will get 2 by S, and here you get 3. So I should write here the transfer function y upon R as a. Here you will get twice by S plus 3 P1 P2 to forward path. How many loop gain in this question? We have only one loop gain, guys, because all the signs are plus only. So what is the advantage in this question? Without using notebook and pen, you can easily solve this question. Even without using notebook and pen, you have opportunity to solve this question. Why? Because here loop gain is positive. All signs are positive. So it means whatever the loop gain, it will have a positive gain. And in the del formula, in the SFG formula, the denominator part is 1 minus del. It means the del value is 1 minus individual loop gain. Individual loop gain is positive only. It is 1 by s only. So that's it guys. When you will take LCM, you will get 2 plus 3s upon s, upon you will get s minus 1 upon s. So s's get cancelled out. So your ultimate answer will be twice plus 3s upon s minus 1. Yeah. This will be your final answer, guys. So it is nothing but y by r. 2 plus 3s upon s minus 1. 2 plus 3s upon s minus 1. Correct answer will be option number C for Chennai Super King. Option number C. I hope you guys getting the same, guys. I hope you guys getting Pratik Kumar. Shabash, mere beta. Just share it to maximum, guys. Just share it to maximum. This is again a control system question. I'm having one more question for you guys. This is again very important and interesting question. I have a complete data for that particular question also. So I'm going to write that particular data here. What is the question? I'm writing the complete question. Consider a unity feedback system. Consider a unity feedback system consisting of the plant GS, consisting of the plant or that लिख देते हैं system, consisting of the plant system GS, okay, and GS complete consisting of the plant that is GS and PI controller. So this is the first line given in the question. I have mentioned in a short form. Let the KP value is equal to 3. KP value is 3 given, guys, and KI value is also given, that is 1. For the unit step input, the final value of the controller. This is very good question, guys. Final value means you have to apply the final value theorem. Final value of the controller, two questions has been asked here. Final value of the controller output and the plant output are. So my dear student, in this question, first of all, GS value is also given to you. And what is GS value given to you? GS value is given in this question is 1 upon s minus 1. So this is the only question which is given in the exam. Now, first of all, you have to design a system which is having a unity feedback system. Input is also given in unit step, as well as the PI controller also you need to achieve. You need to attach. It means here we are having plus minus unity feedback system. I will attach here PI controller. Do you know the transfer function of PI controller? It is nothing but KP plus KI upon S. Yeah. And here GS will come, sir. So what is GS value given? GS value given 1 upon S minus 1, sir. And it is a unity feedback system, so we can apply this. So this diagram you need to make in the examination hall because it is not given in the question. Because it is not given in the question, you have to make this diagram. Now examiner is asking for this is the plant output. This is the plant output. Okay, so I must write here. This is my plant output. And what is the controller output? It is my controller output. It is my controller output. So first of all, examiner asking the plant output final value or controller output final value. So if I will find the plant output final value, then I must find the transfer function first of all. If I will find the transfer function, then what I will get? If I will write the transfer function, guys, then what I will get? I am just making here a common slides. So a blank slide here. So transfer function will be CS upon RS. Transfer function will be what, guys? CS upon RS. You should write here GS upon 1 plus GS because the unity feedback is there. So we have an advantage. Even this term I can keep as a, KPS plus KI upon S. KPS plus KI upon S. So what you can do, GS upon 1 plus GS. So I must write here KPS plus KI upon S. KPS plus KI upon S. KPS plus KI upon S upon 1 into S minus 1. So this is GS upon 1 plus GS. It means again KPS plus KI upon S into S minus 1. So when you will take the LCM, guys, what you will get? You will get now this term KPS plus KI into S minus 1 plus KPS plus KI. Is it clear, बच्चों? तो ये है आपका overall transfer function, but examiner is looking for you आप CS बोल दो, YS बोल दो. So if I talk about the output CS upon RS, your unit step input I need to cross multiply. So what is the unit step input? RS 1 by S. So when I will multiply, you will get this. So ultimately you will have a KPS plus KI upon. This term get cancelled out. So here is S into S minus 1 plus KPS plus KI. And when you will apply the steady state value, so CSS क्या हो जाएगा यहाँ? Final value is nothing but CSS equal to limit S tends to 0, S into CS. So this one get cancelled out. And now you need to put S equal to 0. So this is 0. This complete part 0. This is also 0. So you will get actually KI upon KI. So KI upon KI get cancelled out. So answer is what? 1. It means if you will see the options smartly, dear student, here options are also given. I am writing the options here A, B, C, D. So here options are infinity, infinity. Here options A is infinity, infinity. Option number B is minus 1 and 1. Option number C is 1 and 0. Or option number D is 1 minus 1. So tell me, first value is representing the controller output and second value representing the final value of plant output. So in the plant output we got only one option satisfied, that is option number Bombay. So correct answer for this question option number B only. However, if you wish to check the controller output also, then how you can check, guys? If I go for the controller output, no one will give you such type of explanation for this question, dear student. Many faculties that directly say that controller output aa gaya, option laga do. But if the plant output aa gaya, option laga do. But you should also know how to calculate the controller output. For the controller output, you need to take output this, but input is RS. So how many forward paths? Forward path is only this, and loop gain is remain same. So KP plus KI upon S in numerator. So I am writing here. If I will take the controller output as a YC, so YC is the controller output, then my final answer is what? YC upon R will be what, guys? KP plus KI upon S. So I can take the LCM also, KPS plus KI upon S in the forward path, and loop gain will remain same, sir. Loop gain will remain same. What is the loop gain? Complete term. So 1 plus KPS plus KI upon S into 1 upon S minus 1. That is nothing but the loop gain, guys. That is nothing but loop gain. So this is the conventional, this type of explanation, student, you will never get anywhere. They are just typing, okay, ये question ऐसे हो जाएगा, ऐसे हो जाएगा. So in the IMS Gate Academy, you will get the detailed solution with the accurate data. काहे पढ़े हो चक्कर में, कोई नहीं है टक्कर में. Very good, Pratik. Very good. Just share it to maximum, dear student. So when you will take the final LCM now, you will ultimately get what? You will get ultimate KPS plus KI. Student, or motivation is just depending on you. SS katega, but after LCM. So just share it to maximum, guys, so that our all mentors will be enough motivated because we are working hard for you guys. Our mentors also appeared for the GATE exam just for you, so that we will have a fast analysis. So dear student, here when you will take LCM S into S minus 1, KPS plus KI, and finally you need to apply final value theorem, because this time again YC equal to R is 1 by S. R is 1 by S, limit S tends to 0, S into 1 by S cancel out, and remaining part you need to put the value of Kp into Ki upon. So S minus 1 also will be in the numerator after taking LCM. S minus 1 also will be there. So here S minus 1 also there, and here student S into S minus 1 plus KPS plus Ki. So when you will finally put this S equal to 0, na, this is 0, it's completely 0, this is also 0, this is also 0. So you will actually get Ki upon Ki into minus 1. So Ki get cancel out, ultimately you will get minus 1. So this is the final proof. You will get minus 1 here also. So option number B for Bombay is absolutely correct. However, this controller value is not required in the question to comment on the option. But as I told you, we are providing the complete explanation, detailed solution here. Okay. So now I would like to invite our next faculty member. We're having the next subject. Yes, we can discuss the complete question paper. Yes. Okay, guys. So you just come and just first of all, I think our Vipin sir also appeared for the GATE exam today, to take all the inputs from the examination hall. So tell me first of all, how was the actual exam?
So hello student, welcome to the IMS GATE Academy. I hope you are liking the analysis that we are right now doing. So the level of question paper was not easy, and it was not too tough for those students who were continuously preparing. But what I was seeing, every question was a little bit tricky. It was not.
So that is why all the students are saying tough.
But for those students who are continuously following our GATE score booster series or revision series, I think that paper was a little bit easy for them, because so many questions I have seen directly appear from our GATE score booster series.
Very good.
So I'm just going to solve one question, and you can just go back in our playlist and you can see that was the question that I have discussed, the question number 2 in the GATE score booster series of session 1.
Very good. So you can have the solution of this particular
Yes, sir.
question. I'm just coming, guys.
So guys, how was the power electronics and power system? What is your opinion about power electronics and power system? This year, the questions from power electronics, last year the weightage of power electronics was very high, approx 12 to 13, but this year the power electronics has a little less weightage in this paper. And the questions from power electronics were not too tough, but they were a little bit tricky. And the questions of power system, that was too much tricky. I hope you have solved all the questions. So I'm going to discuss the first question that I have from the switch realization. Across the year, I was telling that you will definitely get a question from switch realization. So my words have become true. So we have a question from switch realization right now in this paper. So the question was, we had a switch. And it was given that this switch is blocking a voltage of one polarity only. So this switch was blocking the voltage of one polarity only, and it was able to carry current in both the direction. So it was carrying the current in both the direction, but it is blocking the voltage of only one polarity, the positive voltage. Now the options given to us was the first option that we have, in which we have the parallel and series combination of BJT and diode. So this was the first option that we have. So what was the correct answer, guys? Have you attempted this question? What was the correct option? I hope you have solved this question. And the second option that we have, in that option, the BJT was connected, the diode was connected in a different manner. Here the diode was connected in this manner. Again, we have a diode in parallel as well. Okay, and option C and D were, option C that we have is, we only have a BJT and diode connected in parallel like this. And option D that we have, that has too many switch. So many students were feared by seeing this particular question, isn't it? So this was our fourth option that we have. Now, which options were correct? According to you, which options were correct? This was an MSQ question, okay? This was an MSQ question. So here we have options C and D correct. What was the right answer, students? Yes, sirs, very good. Option C and D were correct, okay? So how we have solved this question? C, option C and D, I am writing only these options here. So option C in option C we have a BJT and we have a diode, okay? So for BJT, you know, for BJT, how the BJT is being realized? For BJT, you know, it is able to block the positive voltage and it is able to carry the positive current, isn't it? And when it comes to diode, if we have diode connected in this manner, then for diode, what will be the switch realization? The diode is able to block the negative voltage and it is able to carry the positive current, isn't it? So this is the realization of diode and BJT. Now BJT and diodes are connected in parallel. So when they are connected in parallel, what you have to do? In parallel, we have common voltage but different current, isn't it? So what we have to do? We have to take common voltage and different current. So what will happen? The common voltage here is what? What is the common voltage that we have? And current we have to take both, okay? We have to take both currents when they are switches are connected in parallel and we have to take common voltage, okay? So what will happen? Thank you Prateek, okay? So what will happen? How do we realize this switch? We have to take both the currents here, okay? But if you see, the diode is connected in this manner, isn't it? The diode here is connected in this manner. So for this switch, what will happen? For this switch, this will be able to block positive voltage and this will be able to carry the negative current, isn't it? So for this and this figure, what we have to do? We have to take the parallel combination of these two. So in parallel, what happens? The common voltage will be there and both currents will be there, isn't it? So see, in our switch, what we have, the switch is able to carry current in both directions. It is a bidirectional switch and it is a unipolar switch. So option C is the correct match for this, isn't it? Similarly, if we match this switch, so this much switch we have realized, isn't it? So for this much combination, what we have? For this much combination, what we have realized is, for this much combination, the switch realization is, what we have seen is, it is able to block the positive voltage and it is able to carry current in both directions, isn't it? Now what happens? Now we have added one more switch in series of it, isn't it? So when you will add one more switch in series, then what happens? Is this the option D? Yes. So when you will add one more switch in series, then what happens? For this combination, what we have to see? We have this realization for this circuit, this switch combination. Now we have a series connected diode, okay? So for diode, what is the switch realization? For diode, if it is connected in this manner, the switch realization is like that. It is able to block the negative voltage and able to carry the positive current, isn't it? Now they are connected in series. So when the switches are connected in series, what we have to do? When the switches are connected in series, they will share different voltage but common current. So what will happen when you will do this analysis? What will happen? When the switches are connected in series, they will be able to carry same current. So if we have to take the common current will be like this, and different voltage we have to take, so different voltage will be like this, isn't it? Now what we are doing, we are adding one more diode to it. We are adding one more diode to this combination, isn't it? So now we have this diode, and after that, what we have to do? After that, we have to add one more diode to it, this combination. So now if we add one more diode to this combination, after that, what will happen? Now if you see this diode is like this, isn't it? This diode is like this. So for this diode, what will be the switch realization? In this diode, it will be able to block positive voltage and it will be able to carry the negative current, isn't it? So now what we have to do? We have to take the parallel combination of these two switches because these are connected in parallel. So when the switches are in parallel, what we have to do? we have to take the same voltage and both current. So from here in these two figure, if you take the same voltage, and if you take different current, what will happen? The common voltage of these two is the positive voltage, and if you are taking both the current, then the current will be positive and negative both as well. So again you can see this switch is what? This is a unipolar bidirectional switch, and that is the requirement, isn't it? We have to realize the switch which is a unipolar switch because it is blocking only the positive voltage and it is carrying current in both the directions. So again option C and option D are the correct option. So I hope you have secured 1 mark very easily. As far as this question is concerned, we have discussed this question in our GATE score booster series. So if you are following the GATE score booster series, I think we are helping you in the best manner in that. Now after that we have one more question, and that question was very easy. So after that we have one more question, and that question was very easy, and the question was, in this question, this was from choppers. Now this year there was no question from inverter, and that is very shocking, isn't it? This year there was no question from inverter, and that is very shocking because inverter is a very important topic from power electronics. Even the weightage of power electronics this year was very less. Okay, so I was not expecting this so many less questions from power electronics. At least power electronics should have given you 10 marks of question, but this year number of questions were only 4, and the weightage of power electronics was only students of 6 marks. So this is very surprising in this year papers, isn't it? Now this was the question. This is the switch number S1, this is switch number S2, this is diode D1, this is diode D2, this belongs to chopper, and we have a supply voltage of 20 volt, and this circuit is supplying a load of 10 ampere, okay, 10 ampere load it is supplying. And what was given and what was confusing in this question was, we have gate signal for S1 and S2. So gate signal for S1 was given to us, and the gate signal for S1 was like this. This duration is 3 and this duration is 10. Time was given in microseconds, okay. So time was given in microseconds. But what was so confusing in this is the high state of switch, this is the low state of switch. So what was so confusing in it, when we are giving gate signal for S2, so here we have the gate pulses for 5 to 8 seconds, and that is where most of the students were confused. So tell me guys, whenever switch S1 is on, isn't it? Whenever switch S1 is on, the load and source are get connected, and whenever we have switch S2 on, the load gets sorted, isn't it? So at that time when the switch S2 is on, we will be getting no voltage at the output, and whenever we are looking forward in Jayanagar offline class, Bipin sir. Okay, thank you so much. So whenever we have switch S2 on, load will get shorted, isn't it? So at that time there will be no voltage. So guys, if we are calculating the average output voltage, then average output voltage will be what? And the data that is given to us, in which we have the frequency as well, and the frequency was 100 kilohertz, and you have to calculate what will be the average output voltage. Okay, so students were confused relating to D1, D2 and S2 operation. So whenever we have S1 on, the load and source get connected, so output will be there at the load terminal. Whenever we have S2 on, at that time what will happen? The load gets sorted and the output will be 0, isn't it? So we are getting the output voltage only at the duration when the switch T1 is on, switch S1 is on. So what will be the output voltage during that time? The output voltage during that time you may calculate, that will be equals to Vs into T on divided by T, isn't it? Vs is given to us, this is 20 volt, T on will be, this is the duration which is called as T on duration. So T on duration will be what? It is given 3 microseconds, okay, 3 microseconds, and the time, total time. So we have frequency, so time will be what? 1 by f. Okay, so if we put these values here, so frequency is given 100 kilohertz, so 100 into 10 to the power 3 here. So what we will get? We will get 6 volt of answer. 6 volt as answer, isn't it? So I hope you are getting the same answer for this question as well. Okay, so it was a very tricky question. It was not an easy question. So those students who have good concept, those would have solved this question easily, but I think there was so much confusion, so much trick in this question, so this was not an easy question at all. Okay, now after that we have one more question, and that I believe was so easy, and each one of you must have solved this question. Okay, so what was the data related to that question? In this question we have, let me draw the circuit diagram of this. So in this question we have a thyristor, and it has been supplied through a 100 volt of battery, and the load is 4 ohm. Okay, the load is 4 ohm. Now LC circuits are connected to it. Now what has been given is, assuming latching and holding current to 0, assuming the latching and holding current to be 0, assuming latching and holding current to 0, latching and holding current was equals to 0, and T is turned on at T equals to 0. T is turned on at T equals to 0. So T was turned on at T equals to 0. What we have to calculate is the duration in microsecond for which T will conduct. Okay, what you have to calculate is, calculate the duration. We have to calculate the duration for which T will conduct. The duration for which T will conduct in microseconds. So this was an NIT question carrying 2 marks with it. Okay, it was carrying 2 marks, NIT type of question, and believe me, this was a very easy question. A lot of things are given to confuse you, but you don't have to confuse, isn't it? See, this is an LC circuit, isn't it? So whenever T will be on, there will be a current circulating here, and that current we called as IC current, isn't it? And you know that current IC is given by IP sine omega not T, isn't it? So this will follow the sine curve. Now you can tell me the thyristor will be turned on here, and it will remain on up till this duration. Now how to calculate this duration? This duration will be at omega naught T equals to pi, this switch will be getting off, or thyristor will be getting off. So what will be the conduction time for thyristor? It will be pi by omega naught, or pi under root LC. So pi is 3.14 and under root LC. L is given to us. L was equals to 4 microhenry and C was 1 microfarad. Okay. So when you will put the values here, L is 4 microhenry and C is 1 microfarad. So you will get 6.28 microseconds as answer. So what is the answer here? The answer is 6.28 microseconds. So all you need to do is to remember this formula, pi under root LC. I have seen other people are calculating different things, so I just want to confirm you. The time for conduction of this switch has been asked, isn't it? So this is how you will solve this particular question. It was very easy question out of all the questions from power electronics. So I hope you would have solved this question very easily, isn't it? Again, this is a thing that I have told you during the revision series, that this year you might get a question from the LC circuit, and you can see here LC circuit has appeared in the exam.
So hello students, welcome back. Now we will going to start the solution part for the electrical machine. All right, so we will see some question related to the DC machine, induction machine, and first of all I will going to start with the induction machine question. So let us see the first question over here. So a 10 pole 50 hertz 240 volt it is given. Just a second. So it is given that 10 pole 50 hertz 240 volt and single phase. This is a question from the single phase induction motor, all right, and which is runs at, let us say, NR, that is the rotor speed, which is runs at 540 RPM, which is driving a rated load. The frequency of the induced rotor current due to backward field. So we need to find the frequency F due to backward flip. Now the question is pretty much simple, just you need to use your basics, which is that the backward frequency is given by SB into F. What is SB? That is backward slip, which is 2 minus SF, that is forward slip, into F. So your SF is what? Synchronous speed minus rotor speed divided by NS. So NS is 120 F by P. So this is 120, let me write here, NS 120 into F is 50 divided by number of pole is 10, which is 600 RPM. So substitute here, 600 minus 540 is given divided by 600. When you solve this, you will get the answer as 0.1. Now substitute this SF here in the FB. So your FB will be equal to 2 minus, in this formula, 2 minus 0.1 into supply frequency, F is 50. So when you solve this, you will going to get the answer as 95 hertz, which is the correct answer for this particular question. So the option that were given in the exam as 100 hertz, option A, option B 10 hertz, option C 5 hertz, and option D, that is 95 hertz. All right, so the correct answer for this particular question is 95 hertz. Now let us move to the next question that we have right now is from our induction machine again. So this is the question from the match the following type, where mode of operation is given as list A is mode of operation. All right, so in that part A is generating mode, B is motoring mode, and C is plunging mode. Plunging mode is also known as braking mode. And in the list B, we have a range of slip. All right. Now see here, the P in the range of slip is from 0 to 1, Q 1 to 2, and R minus 1 to 0. And the option that were given in the exam is A to R, B to P, and C to Q. B, A to R, B to Q, and C to P. C, A to Q, B to P, C to R, and D, this is A to P, B to R, and C to Q. So this is one mass question and MCQ type. All right, now see here, in the generating mode, your slip will going to be negative. So for A, it will match to R. Now motoring mode, as we know that the slip is positive and it varies from 0 to 1, and this is given in B. And the last one is the plunging mode, which is also known as a braking mode. And for the plunging mode, the range is or you can say the slip is always greater than 1. So C will match to Q. So A, R, B, P, C, Q, which is given in option B. So option B is the correct option for this particular question. And for this question, it is again a 1 mark question in the given set. All right. So we will see the. All right. So let us see some more question over here. I hope you have got the solution. All right. So the question is pretty much simple. I have not expected such kind of question from the IIT Kanpur itself, because these questions are very simple. Even you can say that the IN student who are going to appear in the next week definitely can get a question from this format or this kind of concept. All right. So just use the basics and always try to remember this formula. I think in GATE 21 or 22 we have got the same question like this manner, where the poles and the frequency were given to us, and we are asked to find the backward frequency related to the induction machine. So in the recent trend, we are seeing that not only from the 3-phase induction machine itself, the GATE authorities are again asking the question, and they are showing the interest again from the single phase question topic. All right. And this is again a very simple question. Just you can say that this is a basic question, theoretical question. If you have read the academic level very clearly and crystal clear manner, then definitely you should answer this question in a 5 second, within a 5 second, or you can say under the 5 second as well. All right. So let us move ahead with some more questions. Let me see what question we have here right now. Okay. So let me add the page over here. Just a second, guys, just a second. So how many of you have got the solution? Please let me know. Let's move ahead with the next question in the machine. The next question is again of 1 mark here, and it is asked to find the answer to nearest integer, and I know that most of the student means not most of the a good number of students have not read this part very. Nikhil sir, so from the electrical measurement, you are the best. Okay, thank you, electrical. So let us see here. This is again a 1 mark question where we are supposed to write the answer in the nearest integer. All right. So in this case, we have separately excited DC motor in which the terminal voltage is 400 volt and 15 ampere and 1500 RPM. Okay, electrical, I have one question from the electrical machine, and if you have attempted that question, so please write the answer in the comment box. All right, so that question was from the watt meter, that is minus 400 watts. So if you have attempted, then please let me know the answer in the chat box. All right, so moving ahead, we have a VTS 400 volt. This armature current is 15 ampere. What else? A constant torque. Again, just a second. Constant torque load at rated speed. Operating from 400 volt DC supply. Okay, this data we have provided with. All right, so let us move ahead. Armature resistance, just a second. The armature resistance is given as 1.2 ohm. Now, it is mentioned that if the supply voltage drops by the 10%, so supply voltage is what? It is decreasing to the decreasing by the 4%. This means that let me take this as VT1, because your VT2 is now become 0.9 times of VT1, 0.9 times of VT1. So this will become VT1. So this will become 360. All right. So in the question it is mentioned that your supply voltage drops by the 10%. Now with field current unaltered. So if the field current is unaltered, let me write here. If field current, which is IF, unaltered, this implies that your flux is constant. All right. So from here, what we supposed to find? We are supposed to find just a second. This is constant, this is unaltered, and this is 360 volt. And here we are supposed to find the value of machine, which is a new speed, which is nr2. Let me write here nr2. All right. So here the two case will going to become. What is two case that we are need to write here? Just a second. Okay. So the case one will be so the case one case 1, we have VT1 as 400 volt and armature current. Just a second, guys. Let me change the color. Sorry, the pen tip. And the armature current, which is IA1, this is a rated current, which is of 15 ampere given in the question. Now NR1, this is 1500 RPM. All right. Now, if you know the diagram of the separately excited DC machine, for the sake of simplicity, let me draw the diagram for you. So, this is the field winding plus minus VF and the resistance RF, and the current here is IF. All right. Now, let me draw the armature part. Plus minus Vt, and since this is a motor, so current will come from the terminal, which is Ia, and here we will have the EMF EA, and armature resistance is given to us as it is given in the question, that is 1.2 ohm, 1.2. So this is the symmetric diagram of the DC separately excited motor. All right. Now, since this is a case 1, let me take all the initial as VT1, IA1 and EA1. Now, write the KVL. Write the KVL from here. You will get VT1, which is equal to, or let me write in terms of EA1. EA1 will be equal to VT1 minus IA1 into RA. So VT1 is what? This is 400 minus IA1 is the rated current, which is 15 into 1.2. So when you solve this, you will get the answer as 400 minus 18, that is 382 volt. Done. So this is the case 1. Next is what? The case 2. in the case 2, your VT2 will now become 360 volt because your voltage has been decreased by the 10%. So it will become 360 volt. And here IA2 is unknown, that we need to find, and again the armature resistance will still remains the same. Now in this case, we will going to take the help of the the equation of the load torque, or you can say the electromagnetic torque. So under the steady state condition, your electromagnetic torque will be equal to load torque. Now since the load torque is constant, it is mentioned in the question, so electromagnetic torque will remains constant. So can I say TE1 will be equal to TE2. So what is TE? TE is equal to phi into IA. So phi 1 IA1 equal to phi 2 IA2. So see here, your flux is constant. This means that phi 1 and phi 2 will both remain constant. So from here you will get IA1 is equal to IA2 is equal to 15 ampere. Done. So again apply the KVL. VT2 will be equal to your EA2 will be equal to VT2 minus IA2 into RA. So VT2 is 360 minus IA2 is again 15 into 1.2. So 360 minus 18 will be 342 volt. Now use the basic equation of the EMF, which is equal to EA proportional to phi into N. So since the flux is constant, can I write this is ultimately equal proportional to N? Yes. So your EA2 divided by EA1 will be equal to N2 by N1. So we are supposed to find the N2 value. See here, we are supposed to find the, let me write here N2, not NR2, N2 value that we are supposed to calculate. So your N2 will be equal to N1 times EA2 divided by EA1. So N1 is 1500 RPM into EA2 is 342 divided by 382. So when you solve this, you will going to get the answer to the nearest integer, which will come out to be as 1343 RPM. So how many of you have got this answer 1343 RPM? So 1343 RPM is the correct answer for this particular question. All right. Let me see how many of you have answered this question as 1343. Please let me know. Please write in the comment box. All right. So let me check. Do we have another question from the machine? All right, so let us move to the next question from the measurement. All right, so in the measurement, it is given that. Okay, let me write the marks first. 2 marks MCQ. All right, so the wattmeter reading W, or you can say P, is given as minus 400 watt from measurement. All right. So the the current through the R phase is given as 2 ampere, and then the power factor of the load that we are supposed to find here. And the diagram is like this. This is 3-phase 400 volt balanced source. And here we have one connection of wattmeter, which is ML, and this is R phase. Here we have a load, which is 3-phase and star connection. All right. So this is R, Y and B, and your potentiometer, sorry, not a potentiometer, a pressure coil. The connection of the pressure coil is like this. It is like this. So this is ML, and here we have C, and this is V, and this is your wattmeter. So this sort of a diagram is look like that. You will going to measure the reactive power. Here a current coil here, from the R phase you will get the IR current. You will get the IR current. So this is the connection where a current coil is connected only in one phase and the pressure coil is connected between the two phase. Then in such case your wattmeter reading will be P, will be given as VL IL sin phi, which is a kind of your reactive power. So the reading is given as minus 400 watt. VL is given in the question as 400. IL is what? Basically line current, which is the IR current. This is the line current, which is 2 ampere into sin phi. So when you solve this, you will get sin phi as minus 0.5. So your phi will be equal to minus 30 degree. Sir, why you have not taken the phi as 360 minus 30 degree, or you can say 180 minus 30, 180 plus 30 degree? No, because the phi angle is a power factor angle which always range between the 0 degree to 90 degree. All right, so your phi will be negative sign. So here negative sign implies that leading load. So but we are supposed to find the power factor. So power factor is what? Cos phi, which is cos of minus 30 degree, and cos of minus 30 is what? Cos 30 itself, and cos 30 is what? 0.866 leading. All right, so 0.886 leading is the correct answer for this particular question. All right, so now let us end up here. Once I will get some more question, I will again come and will solve some more question from the electrical machine. All right.
Hello everyone, welcome to all of you again. So I'm having few questions of maths and one question of aptitude. So let's approach here. First of all, earlier I was not having the data, but right now I'm having the options also. That in this question we were having options 9 pi, 6 pi, 18 and 20. Now we can approach this question very easily. Let me see the comments also. Yeah, okay. So now let's approach here. So as the question is given to us, a square with the sides of length 6 centimeter is given. The boundary of the shaded region is defined by the two semicircles whose diameter are the sides of the square. So we can first of all approach as this is the figure. 6 centimeter is the side of square. Here also the 6 centimeter side of the square. I'm going to convert. Okay, the question is asking about the area of the shaded region. This area. The question is going to ask about the area of this shaded region. So we will use here, first of all, I will find out the area of this one. Then I will approach the required area. So for this we need small difference. So what I am going to approach, I am going to solve, you can see, I am going to write down or draw this spatial square here. So this is the square, you can see, right? As we know very well, this is the complete circle, and if I talk about, this is the 1/4, the quarter circle, the 1/4 of the circle, right? So here we can see, first of all, if I want to find out the area of this region, the area of this region, let me use the different color so that you can see the difference also. Yeah, the area of this region, the complete region, I'm going to find out the area of this one. So how I can approach? I can find out, first of all, the area in this way. So for this one, I can approach that this is the 90-degree angle. So we can approach, this is the 1/4 of the circle, and we know very well that the area of circle is pi r square. If I need to find out the 1/4 portion of the circle, I can write down the area as in pi by 4 r square only. Okay. Similarly, so for this one, I can write down the radius is 9 only, radius is 3 only. So I can write down the area of this region as pi by 4 into 9 plus, okay, I'm going to add here only the same thing, the opposite also. So for this, I'm making dot dot dot. For this area also, I can calculate same way, because this is the 1/4 circle, or this is the quarter circle in the upper portion. So I can find out the area of this one also with the same thing, because the radius is also here 3. For this one also the radius is 3. So we can approach here also pi by 4 into 3 square, that is 9. So my area will be okay, actually for this one, just hold on now. My area, I'm finding the area of the semicircle, but this semicircle including a square also. So if I need, not the semicircle, this is the quarter circle. So this quarter circle is including in the square also. So if I need to find out the area of this one, I need to subtract these two areas from the area of the square, beta. So that's why we can approach it. Yeah, that's why we can approach it pi by 4 9, or 9 pi by 4 plus 9 pi by 4 minus 9. Who's that? Govinda. Yeah, very good. So in this way, we can just take common from here, or we can write down this 9 pi by 2, these two minus 9. We can just take 9 from here common, so it will be pi by 2 minus 1. Now this is the area of this complete region. Beta, look at here. This is the area of this region. Okay. Earlier, I just find out the area of this one and then the area of this one. So right now, I'm talking about the area of this region, which I make as a line. So this is the shaded region for me right now. But the question is asking about the area of, to finding the area of this shaded region. Okay. So what I will do, just look at here. So here we are having, beta, this is the semicircle. Yeah, we can see this green color is a semicircle only. This is the semicircle, and here this one is also a semicircle. We can see we are having here two semicircles. Okay, if I will just, I need to find out the area, I need to find out the area of this zigzag curve. If I will subtract this area from the sum of these two areas, I can easily find out the area. Now how I will approach? Yes, how I will approach? So look at here. So this is the area of this shaded region. Now one more step we have to add here. What we have to do? We have to write down the area, or let me write down the required area. Required area, okay, will be there. This is nothing but the semicircle, and the area of semicircle is pi by 2 r square. Okay, so for r is 3, so I can write down the area of this semicircle, which is pi by 2 into 9. Okay, if I will just subtract, beta, look at very carefully. If I will just subtract from this semicircle this shaded region, if I will just subtract from this semicircle this shaded region, I will have the area which one of the part which is required from the question. So we can get this thing. So what I have to do, so I can write down 9 pi by 2 minus this area, which I write down as in 9 into pi by 2 minus 1. I can subtract. Similarly, the same pattern we can follow for the upper semicircle also, for this semicircle also. So I can just multiply the whole thing with the 2, and then I can approach it. I hope the question is clear, guys. So now we can multiply. So it will give you 9 pi minus, it will be 9 pi minus plus 18. 9 pi will be gone. So your answer will be 18 only. We are having options, so we can approach. The answer will be 18. We can easily approach to the answer. The result will be 18. So we are having options. The answer will be 18. This was the 2 marks questions, and then this is a very good question of geometry and mensuration. This pattern of question already asked, okay, not exactly, but this pattern of question already asked in the GATE 2021, okay, but right now they just give that this pattern of question has been asked, but right now they just give the question with the one twist. Now the twist is they are asking about this shaded region. So what we have to do, first of all, we have to subtract the area of this one. So that's why we just find out here the area of this shaded region, okay, by this one. Then we just subtracted the area from the semicircle to this shaded region. So I just subtracted the area of semicircle, okay, semicircle minus the area of the given region. Okay, so hence we approached it. So that's why the answer is 18 pi. Now I'm having more questions of engineering mathematics. So let's approach to the one question that is the question of expected number of trials. So it is given to us expected number of trials, for, we are having 2 outcomes. So expected number of trial for the first outcome is given to us, okay, no, expected number of trial for the first outcome of head in a biased coin is 4. So actually it is given to us expected value of x is 4, okay. The one thing is given to us, expected value of x is 4, and they are asking about the probability of getting head in the second trial. Getting head in the second trial. So right now they are asking about the probability. This is a numerical answer type question. We don't have options for this one. So we can approach the question in a simpler manner. The basic question which we used to see in the expected or in the random variable, in that question they used to give us the probability and the question have to ask us about the expected value. But this time the expected value is given to us and they are asking about the probability. Okay, so we can surely approach this question. So we are going to use here the concept of probability only, right? So how I am going to write down here, I am having x and the trial is p. X and the p is the probability. So look at here, it is asking about the trials. X can be 1 trial, 2 trial, 3 trial, 4 trial, and so on. The probability will be as the required probabilities for the getting head. So let us assume the probability for getting head is p, or we can write down the p, and probability for getting tail will be 1 minus p. Okay, we can approach like this way. So we are having the probabilities also. Suppose I am going to make a table for you. Suppose I just get head in the very first trial, then my probability will be p. Yeah, surely. Suppose I just get head in the second trial, then my probability will be, when I get head in the second trial, it means in the first trial I am having head only, so I am having tail only, so it will be 1 minus p into p. Similarly, if I get head in the third trial, so it means I must have the tail 2 times and then head third trial, in the third time. So it will be 1 minus p square into p, and so on. We can go for so many trials. Exactly, guys. So we can go for the so many trials. We can approach it. Now we know very well the formula of expected value is nothing but summation of xi into pi. We are having everything, and it is already given to us as in 4. So we can use this one as 1 into p plus 2 into p, 1 minus p, 3 into p, 1 minus p square whole square, and so on and so on. Okay, up to the infinity term, and it is equals to 4. The expected value is already given to us 4. We can just take p outside from this one, so it will be 1 plus 2p, 1 plus 2 into 1 minus p plus 3 into 1 minus p whole square, and so on, and it is equals to 4. Now for this one we already learned a basic form. This is nothing but we can approach it like this. We can just solve this one, and we can write down the expansion, means this is nothing but the basic expansion only. So we can just write down the expansion as an 1 minus we are having the term as it is 1 minus p to the power minus 2. So we can go for the expansion. This is nothing but the expansion of 1 minus, if I used to write down it as x, so 1 minus x power minus 2. This is the expansion of this one only, 1 minus x power minus 2. If we will open it, then the expansion will be 1 plus 2x plus 3x square, and so on it will be going on. That we already learned in the series concept of the calculus. So we already learned this expansion. So here we can use the concept, and it is already given to us as in 4. So we are going to solve this one as p, okay, and when if I will open 1 minus 1 plus p power minus 2 is equals to 4, 1 and 1 will be gone. I am having p into p power minus 2 is equals to 4, okay. So I can write down that I am having actually p into p power minus 2 as in 4. So from here I can write down the value of p power, or if you want to write down minus 2 plus 1, that is equals to 4. So p power minus 1 is equals to 4. Hence we can write down p is equals to 1 by 4. P is what? P is the probability of getting head. Dear students, P is what? P is the probability of getting head. Now it is not asking me about the probability of getting head in the first trial. What is question asking? The question is asking about the probability of getting head in the second trial. In the second trial. So it means it is clearly visible that if we talk about the second trial, this will be the probability. Means in the first trial, the outcome will be tail, and then in the second trial, outcome will be head. So actually the question is asking to me this value. So we can write down here the required probability will be 1 minus p into p. 1 minus p is 1 minus 1 by 4 into 1 by 4. We can write down 3 by 4 into 1 by 4, which is 3 by 16, but the question is not having options. So we can solve 3 by 16. By solving this 3 by 16, we will have the answer as 0.1875. Sorry, 0.1875. So this will be my answer. So I can write down the answer here also, which is 0.1875. This will be the answer. We can solve like this also. Okay, so in this way we can solve these type of question, which is actually very, very good. And yeah, surely the level of the question is very good. Now I'm having one question from the calculus also, the cardioid question. Let me write down that question also for you guys. The question is, the closed curve in the figure is described. We are having a closed curve in the figure is described okay by r is equals to 1 plus cos theta. Second means the next thing, r is equals to root of x square plus y square. We are having x is equals to r cos theta and y is equals to r sin theta. These values we are having. The magnitude of the line integral, it is asking about the magnitude of the line integral. The magnitude of line integral, okay, of vector field, line integral of vector field means they are asking about the vector field is y vector f vector minus y I cap plus x j cap around the closed curve, around the closed curve. Okay, as I'm not sure about that whether the question is having options or not. If any one of you approach, then guys please confirm the question is having options or not. I'm not sure about this one. So we are having a cardioid. Okay, let me draw the cardioid on the next slide. We are having a cardioid like here. Okay, it is given to us something like this. It is given to us something like this. Okay, and the figure is starting from here. We are having 0, here we are having 0.5, here we are having 1, then 1.5, and this one is the point 2. This is lying between range minus 1.52 plus 1.5. Here it is 0. Okay, here we are having minus 1 and here we are having plus 1. So in this way the figure is given to us. Now first of all we can directly solve this question beta by the help of the Green's theorem. We can use here the Green's theorem concept and then we can solve it. So I'm going to use here the concept of Green's theorem only, as the function is given to me minus yi cap plus xj. Okay, as we know very well, the Green's theorem says if we are having the p dx plus q dy form, and it is always is equals to del q by del x minus del p by del y into dx dy. So we can use this concept of Green's theorem here. We are having the question in the line integral form, and we need to convert this one into the double integration, and we can solve it. So when we will convert this one, so we can write down f dr can be written as minus y dx plus x dy. Okay, here we can use the Green's theorem. For here p is equals to nothing but minus y, q is equals to nothing but x. If I will find from here del p by del y, it will be minus 1. If I will find from here del q by del x, it will be plus 1. Right? So yeah, 3 pi, very good Vishal, shabash. So from here we can solve. Vishal, had you approached this question in the exam? So can you tell me whether we are having options or not? Okay, so 1 and 1. So now I can use, with the help of the Green's theorem, I can write down the solution as in double integration. I am having 1 minus 1 and it is dx dy. When we will solve this one beta, it will give us the result as in 2 into dx dy. As we can take common 2, and here it will be the area of the given closed curve. The closed curve is nothing but the cardioid only. So area of the cardioid, right? Okay, it was NAT. Yeah, sure. So area of cardioid only. So now from here we can now from here we can solve the question in a slightly different manner. Even now we can, if you know the area of cardioid, you can use the concept of area of cardioid. If you don't know, then we can solve whenever we are having a basic concept of closed curves. If we are having any closed curve in a polar form and we have to find out the integration, we can solve with that concept also. Okay, so we can write down here. So let me write down area of that is a star mark. You can write down area of any closed curve. We can use this small thing here also. So it will be very easy for us, means without putting the limits of 2-time integration, without doing this question in the 2-time integration, we can solve it directly. So area of any closed curve, okay, and when it is given in the polar form. So we can use here the concept which is a quite easy concept, that integration I is equals to 1 by 2 into r squared d theta. So here r is nothing but 1 plus cos theta. So I can use here, and the integration limit, as I can see the cardioid, we are having a closed curve. So it will be lying between 0 to 2 pi. The angle will be lying between 0 to 2 pi. So we can use here this concept. Okay, first I am finding this area, then I will put the value of area here. Okay, then I will put the value of area here. So or if we want, then we can just take common here only, not there, here in this one. Okay, I will put the value. So I can go with the 1 by 2. We are having r square is 1 plus cos theta whole square d theta. Okay, the limits will be 0 to 2 pi. When we will solve it, line integral se kiya, exactly. When we will solve it, we are having 1 by 2. If we want to solve it, you can solve it directly, or you can go with the 1 plus cos square theta plus 2 cos theta, okay, d theta. After solving this one, after solving and after putting the values, we will have the result from here as an Okay, and if we can do one more thing, we can put the value this one only. So this is the required integration or the area. So that's why we can put directly. So after putting the values, we will have the result as in 3 pi. We can directly solve after integrating. After integration, we can solve the integration. This will be theta. Okay, this will be 2 cos theta sin theta. This will be minus, and sorry, 2 sin theta, and we can put the limits as in 0 to 2 pi. After putting the limits, we can solve it and we can get the result as in 3 pi. This is the first approach. If you think you want to go for both the approach, then you can write down here r, and you can write the limits of r from 0 to 1 plus cos theta, and theta is equals to 0 to 2 pi also. First, second thing. And the third thing, if you remember the area of cardioid, okay, this is the standard result. If we talk about the area of cardioid from here, let me write down that thing also I am talking about. So for this question, we can go with the 3 approaches. First approach is this one. Second approach, I told you about the limits of the integration we can go, and the third approach we can use here, that the area of cardioid is nothing but r into a 1 plus cos theta. If I will just compare with the standard format of r is equals to 2a cos theta, if we are having this type of cardioid, then the area we can use as an 6 pi a square. And when I will just compare here, the value of a will be 1 by 2. I can use the values here, and then I can just solve by the integration. So I can just solve this with the integration. So it will be 2 into, it will be 2 into yes. So in this way also we can solve the question, and it will be 6 pi into 1 by 2 square, and we are having 2 already. So it will also give you the 3 pi. So in all the manners we can solve the question, not integration. This is the bracket beta. Okay. So in all the way we can solve the question, and the result will give you as in 3 pi only. Okay. So I hope this is clear to everyone. I am having one more question, and the last question, dear student, which is of the graph pattern of question. Okay, and let me draw that one also. We can make it this question also very simple. In this question, we are having a graph looks like this one, fx, and the graph is looking like here as it is. Okay, so for this we are having the functions also, options also, and they are asking about for which function the graph is this. Okay, B option is mod x 2 power minus x. C option is x into 2 power minus x, and the D option is x square into e to the power minus mod x. Now, what is the answer? Very good. Let's look at here. So for approaching these type of questions, first of all we have to look the options. Beta, in options, let's look at the option D and option B. We can see in option B and option D, we will not have any negative function, because mod x will be positive always, and this one will be also positive always. So, but here in the graph, we are having the negative point also. So that's why beta, these two options we can easily eliminate, that these two options will not be my answer, because we can easily eliminate these two things. We don't have here the, just wait a minute. Yes, okay. So we can see these two options we can easily eliminate. B and D will be gone for us. Now we are having either A or C. Now let's check. As if I check beta here, my function, suppose I am just taking function C as an x 2 power minus x. I want to check, means this function will exist for the even or odd function or not, means either this function will exist for negative number or not. Then if I will put here at the place of x minus x, it will be minus x 2 into minus minus plus x. But now by putting the minus x, it is not giving me f of minus x is equals to minus of fx. Means this is not the concept of odd function. Neither it is, means for this particular option C, I am not able to identify whether my function is an even function or an odd function. So if we are not able to identify, then how we will sure that this will be the function of the given graph? So we will not go for this option. Let's check for the option C. Sorry, option A. When I will check option A beta, so option C is also eliminated like this way. So we can eliminate option C also. Now we are having only option A, but let's check the result for option A also. When we check for the option A, we can check beta the function is fx is equals to x 2 to the power minus mod x. As I am damn sure, if I will put something here, means if I will put at the place of x minus x, my function will be minus of x 2 into minus of mod x. So my function will become minus of fx. So my function will become odd and it will satisfy the condition. Yes, surely. So this is the only option among the given 4 option which is satisfying and which is fulfilling all the condition to the given graph. So that's why my final answer will be option A for Ahmedabad. I'm not sure about the options, but this will be x into 2 to the power minus mod x will be the final result of this question. I hope guys it is clear to everyone. So we approached the most even each and every question of maths and aptitude here only. So stay tuned to our this channel only, because we are going to deal with the more technical questions here. We are approaching for you. So all the faculties are waiting for the remaining technical questions also. So just stay tuned guys. Okay, thank you.
So, hello students. So again, we are going to continue remaining questions, guys. Okay. So here we are having questions of network theory and analog electronics, guys. Okay. So so here I am just coming with one question of network theory, guys. Okay. So in this question you have given what, guys? So here again this is very good question, guys. So here you are having a 2-port network. Okay, so this is giving to you, there is a 2-port network, guys. 2-port network is given to you. Okay, and here it is connected with a 20-volt source. Okay, and this is connected with the load resistor, guys. So this resistance is given to you RL and the value is 6 ohm. 6 ohm value is given to you. Okay, and this value is given to you 20 volt. Now there is one more resistor which is connected in this way of the value 3 ohm. Okay, now for this 2-port network you have given Y parameter, guys, and the value of Y parameter is given to you. Matrices this is given to you is 5 minus 2.5 and this is minus 2.5 and this is 1. Okay, so this value is given to you. This value is given to you. And what we have to calculate, you have to calculate the power. What you have to calculate? So just you have to calculate the power across this load, guys. You have to calculate power across this load. PL is equal to what? It is not maximum power, it's simple power, guys. Is it clear? How to calculate this value, guys? So if I'm talking about this power, so power is what, guys? So to find this power, what we have to write? We have to write current square into this resistance, guys. Okay, now? So if I'm talking about this circuit, so in this circuit, as this is a 2-port network, so obviously there will be two terminal, guys. So this is V1 and this current is I1, and let us suppose this terminal is V2, and this current is what guys? I of 2. Is it clear? Okay, and if it is clear, so we can write what guys? Y parameter equations from here. Is it okay now? So what is the equation? So if I'm talking about this equation, what we can write here? If I'm talking about this equation guys, so what we can write here? We can write y1, okay, or directly we can write what guys? If I'm talking about this equation y parameter, here I'm writing y parameters guys, y parameters. So y I1 is equal to what guys? So this is y11 v1 plus of y22 or 12, so this is v2, and here I2 is equal to y21 v1 plus of y22 v2. Is it clear? So this data is given to you. Actually this data is given to you. By the help of this data we have to find power across this load resistor guys. Is it clear, yes or no? If it is clear, so how to solve this question guys? So what we can say, if this is I2, so we can assume sir this is minus of I2. Is it okay? Or in simple word we can say sir, as the current is flowing here I2 in this direction, so there will be this drop, and if this is drop, so you can say the voltage polarity of V2 is opposite to the VL guys. Okay, so what we can write here? We can write sir V of 2 is equal to, so this is minus of 6 I2 sir, 6 times I2. Is it clear, yes or no? So let us suppose this equation is 1, this is equation 2, and this is our equation 3. So we can write from equation 2 and 3, what we can write guys? So we can write I of 2, we can write I of 2 is equal to y21, and this is v1, and this is plus of, I'm just writing y2, and in place of v2 we can write minus 6 times I of 2 guys. Okay, just take this value here, so we can write I2 plus, what is this? So this is 6 times y22 I2 plus of y21 v1 guys. Okay, so from here we can say this y2 is common, so this is 1 plus 6 times y22, and this is equal to y21 v1 guys. Is it okay? Is it okay? Yes, just tell me please. If it is okay, then we can find the value of I2 from here guys. So we can write, therefore I2 is equal to, just write this value, I2 is equal to y21 v1. So we can write y21 v1, and this divided by 1 plus 6. So this is 1 plus 6 y22 guys. Is it correct, yes or no? Just tell me please. Okay, is this correct, yes or no? So if you have this value, okay, now it's very simple guys. It's very simple. If you have calculated this value, now it's very simple. Is it okay? Now what we have to calculate? We have to calculate y parameters guys. But here many of the students, many of people's done one mistake guys, is doing one mistake. What? This parameter is given to you. Actually this parameter is given to you, and you are just writing from this y matrices only. You are just writing from this y matrices only. No, it's not correct. Okay, why it is not correct? Because we have this resistor also guys. We have given this resistor in parallel with this two-port network guys, with this y matrices only. Okay, now first of all we have to calculate y parameter of this guys. Okay, so let us assume this is our ya. Okay, now what we have to calculate? We have to calculate yv guys. Okay, so how to calculate this value? How to calculate this value? So again we can say sir, this will be like, to find the yb, to find the value of yv, we can say this is nothing but this only. Okay, so this is 3 ohm, this is our plus minus v1, this is our plus minus v2, this current is I2, this current is I1. So from here we can directly write YA matrix, guys. So this is YB na, yeah, so this is YB. From here we can write YB matrix directly from here. So how, sir? Because this is what, guys? Pi network. So for pi network, as we know, so this is YA plus YB, so this is nothing but 1 by 3 minus of YA, so this is minus 1 by 3, so this is minus of YA minus 1 by 3, and this is YA plus YC, so this will be 1 by 3, guys. So this is the value of YB. This is the value of YB, sir. Is it okay? So now if I am talking about what, guys? Net Y, so we can write what? Net Y is equal to YA plus of YB, sir. Plus of YB. So what is the value of YA, sir? So YA value is given to you. So this is 5 minus 2.5 minus 2.51. So this is 5 minus 2.5 minus 2.5, and this is 1. This value is given to you, and plus what is this? So this is 0.33, this is minus 0.33, and this is minus 0.33, and this is 0.33, sir. Okay. So if it is okay, then what we can write, guys? We can directly write the value of this. So from here we can write Y parameter, or we can say Y matrix. So this is how much? So this is 5.33, sir, and this value is minus of 2.83, and again this is minus of 2.83, and this value will be 1.33, sir. Okay, is it clear? And if it is clear, so from here we can write, sir, this is our Y11, this is our 12, 21, and this is 22. Is it clear, yes or no? Is it clear, yes or no? Respond please. Okay, and if it is clear, so from here we can directly write the value of YT, sir. Value of IT. Okay, now, so I2 is what? So I2 is nothing but, if I am talking about I2 value, so we can write, sir, therefore I2 is equal to, so this is Y21, so this is nothing but minus of 2.83, guys. Okay, and this is multiplied by V1, so the value of V1 is given to you, so this is 20 volt, guys. Okay, so we can write this is 20, and this divided by what, sir? This divided by 1 plus, so this is 1 plus 6 into Y22, and Y22 is 1.33. Okay, so this value is given to you. Actually this value we have calculated, we can calculate from here only. So just tell me the value of Y22, guys. Sorry, I2 only. Just tell me the value of I2, guys. Just tell me the value of I2, guys. What is the value of I2? Just tell me please. Just tell me the value of I2, guys. Okay, so I think it will be minus of 6.29 something. Okay, na? So this is minus of 6.29 ampere. So this is the value. I think this will be the value, guys. Okay, so just check once. Just check once. Okay, now if you have this value, what we can write, guys? So from here we can say, as we know, sir, the power PL is equal to I2 square into, sir, 6. So we have the value of what, sir? Value of I2, which is 6.29. So we can write minus of 6.29 whole square into 6, sir. Okay, so just you have to calculate this value. This is the answer, guys. This is the correct answer only. This is our correct answer. Is it clear, yes or no? Is it clear, yes or no? Just comment please, guys. Just comment how many of you got the correct answer only. Just respond, all of you, how many of you got the same answer. Just respond please, guys. Okay, is it okay, guys? Very good, very good, very good. Now let us move to the next question, guys. So here, if I'm talking about the network theory questions, guys, so we have discussed all the questions which is from network theory. Okay, and if I'm talking about network theory, so in the network theory 237.38, yeah, very good. So this will be how much? So this will be 237.38. So this is the correct answer only. So this is the 237.38 watt is the correct answer. Exactly. Very good, Maria. Okay. Now, if I'm talking about network theory, guys, so network theory questions are moderate, guys. Actually, if I'm talking about basics to moderate is from network theory. Okay. If I'm talking about the next one, so next I'm just going to discuss is what? I'm just going to discuss analog electronics, guys. So here I have analog electronics question also, and it is given to you. For analog electronics question, it is given in this circuit a Zener diode is given, okay, with the BJT. Okay, so I'm just drawing first. We have this circuit, guys. So this circuit is given to you, and here it is connected with a resistor, and this is connected with the diode, guys, Zener diode. Okay. Yeah. So, and it is connected with a resistor where we have to calculate current, guys. Okay. So we are having this circuit. So value of this is 25 volts, and this resistor is of 7k ohm. This is Zener diode, and this is 10 ohm resistor, and the value of this resistor is 20 ohm. Okay, and the arrow is here. Is it clear, yes or no? And for the given circuit, it is given to you the value of the Zener diode VZ, breakdown voltage of the Zener diode, is 5 volt, and beta is given to you 99. Okay, and it is given VBE is equal to 0 volts, and you have to calculate current I here. So this is the question, this is the problem, guys. Okay, so again this is very moderate question, guys. Okay, so if I'm talking about this question, so to find this value of I, what we have actually, sir? So we have the base current IB, this is our base current, this is our emitter current, and this is collector current. Is it correct, yes or no? So this I will be equal to IE if this will be what, guys? This will be off. Okay, na? Or this will be different value by just checking, or we have to check this what, guys? Zener diode, but just by checking the value of this Zener diode or conduction condition of this Zener diode, we can comment about this value of I, guys. Okay, so totally if I'm talking about this question, so basically we have to check this Zener diode, is it on or off, or is in breakdown condition. Is it clear, yes or no? So let us check, guys. Let us check how to calculate this. So now if I'm talking about this, so we can say the value of voltage is this NVA, and this is VC, guys, because this is anode terminal and this is cathode terminal. Okay, so let us assume this is VA and VC. Okay, and what I'm doing, I'm just removing. Okay, I'm just removing this Zener diode, guys. So let us remove this Zener diode. Let us remove this Zener diode, guys. Okay, so I'm just removing this Zener diode. And what we have to do, we have to calculate the value of VA minus VC across this Zener diode and check either it is on, off, or in breakdown region, guys. Okay, now, and then we'll comment about the I value also. So right, first of all, if this is open, so the current will be 0, guys. Then this current will be 0. Then this current will be 0. Is it clear? So this will be 0. So if this is 0, then this IB will be here only. Okay, so this is IB, this is IC, and this is I, guys. Okay, and as you know, the drop across this is 0 volt. Drop is given to you, this is 0. So here we can write 1 KVL, guys. Okay, and here I am assuming this is ground. This is ground. Okay, so let us write KVL. So I am writing here KVL only. So write KVL guys. Write KVL. So what is the KVL guys? So just write KVL equation. So this is minus of 25 plus of 7 into 10 to the power 3 times of IB, and this is 0 plus of 10 times IE and plus of 20 times, because this current is 0, so obviously this will be IE only, this will be IE only, so this is plus of 20 times IE, and this is equal to 0 sir, and this is equal to 0. Now we can write what? We can write 7 into 10 to the power 3 times IB, and in place of IE, actually this is 30, and in place of IE, or we can write IE is equal to 25. So here, as we know, IE is equal to 1 plus beta into IB guys, okay, if the transistor is in active mode. So what we can write? So therefore we can put the value of this. So as beta is given 99, so therefore we can write IE is equal to 100 times of IB guys. So just put this value guys. So what we can write? So we can write here, so this is 7 into 10 to the power 3 times of IB plus of 30 into 100, so this is 3000 into IB, and this is equal to 25 sir. So therefore we can say, so this is 7000 plus 3000, it is 10,000, so 10 into 10 to the power 3 times IB is equal to 25. So therefore we can write sir, IB is equal to 2.5 milliampere sir. So this is our first equation. You can say this is our first equation. Is it clear, yes or no? Is it clear, yes or no? Just tell me please. Okay. Now if it is clear, so what we can write sir? So from here we can say, if IB is known, we can write sir IE value also, and IE is nothing but 100 times of IB. It means that this is 250 milliampere sir. And let us suppose this is our second equation. Let us suppose this is our second equation. Why current across 20 ohm resistor parallel to it short? What you want to write, Manaria? Why current across 20 ohm resistor parallel to it? Actually, if I am talking about this 20 ohm resistor, just try to understand this point. Here this current is IE, is it clear, yes or no? Just tell me first. Is this current is IE, yes or no? Now if this is IE and this is open circuited, because we are assuming this is open circuited. Actually what we are doing here, guys, we are just finding on or off condition of this Zener diode guys. Either is the Zener diode is on condition, in off condition, or in breakdown condition. We are just checking the, okay na. So you can check this condition in two way also, by the help of open circuit method or by the help of short circuit method, okay. But we are using here open circuit method to test the operating condition of this Zener diode. Is it okay? So in this way, if this current is 0, so obviously this I is equal to IE guys. Is it okay now? Very good. Now if it is clear, so what we can write guys, so from here, if we have the value of IE, IB, we can calculate the value of VC and VA sir. Is it okay now? So let us find this value. So here if I am talking about this value guys, so what we can write? We can write, if I am talking about this value VC sir, so VC, to find the value of VC, just start from there and go to ground sir. So here I am writing the value of VC. So value of VC is what? So this is what sir? So this is plus minus. So we can write, this is how much sir? So this is minus of 7 into 10 to the power 3 into IB is how much sir? So this is 2.5 into 10 to the power minus 3, and this is plus of 25 sir, plus of 25. Is it okay, yes or no? So just calculate this. So this will be cancel out. So we can write, this is 7 into 2.5. So this is how much guys? So this is 7 into 2, so 14 and 3, so this is 17, minus 17.5 plus of 25 sir. Is it clear? Just check once, okay. So this value will be 7.5 volts sir. So this value will be 7.5 volts. Is it okay, yes or no? Is it okay, yes or no? So if it is 7.5 volts, now we can calculate this value also. Again we can say what? To find the value of VA, what we have to do, just start from VA and go to ground, sir. So basically this is ground only. This is ground only. Okay, na? So just check the drop across this, guys. And if you will find the drop across this is anything, so that will be the value of VA. Okay. Now, how to calculate this value of VA, sir? So we can say here, VA is what, sir? VA is nothing but 20 times IE, sir. Is it clear? So the value of I is calculated here. So this is 250 milliampere. So this is what, guys? So this is 25. We can write 20 into 25. So this will be how much? 5 and 5000. So this will be 5 volts. Is it clear, yes or no? Just tell me, please. Is it clear, yes or no? Just tell me, please. Okay. So here we can we can write VA minus VC value. So just calculate this value, guys. Here I am writing, sorry, here I am writing what? So if I am talking about VA minus VC, so VA minus VC is how much, sir? So VA is what? VA is 5 volt. So this is 5 minus of 7.5, and you can take mode of this also, okay, to find the VZ. So this will be 2.5 by 2.5 volts. Actually this is nothing but VC minus VA actually. Okay, now voltage across the Zener diode in the reverse bias condition. Okay, and this is what, guys? This voltage is less than VZ, and this voltage is less than VZ because VZ value is given to you, and this is 5 volts, guys. So what we can say? We can say here this Zener diode which you have given, guys, this Zener diode is in the off condition only. Okay, because it is operating in the reverse bias condition, but the voltage across the Zener diode is less than breakdown voltage, guys. Is it clear, yes or no? And if it is clear, so in simple word we can say this will be open circuited only, and if this is open circuited only, so the current through this Zener diode will be always 0, and if this current is always equal to 0, then this IE is nothing but I value. So obviously we can say the value of IE is equal to what, sir? So this is the value of I. This is the value of I. Is it clear, yes or no? Just tell me, please. This is the value of I. Is it clear, yes or no? Just tell me, please, guys. Okay. So what is the correct answer, sir? So here we can say, if I am talking about the value of I, so I is nothing but IE, sir, and the correct value is 250 milliampere, and this is the correct answer, sir. This is the correct answer. Okay, very good. Very good, guys. Very good, guys. Okay, now let us move to the next question, guys. So next question we have from analog electronics only. Okay, so again this is very conceptual question. You can say this question is from analog as well as network, combination of both. Okay, so just writing this question, guys. Just try to understand this question. Okay, and you have to recheck also how many of your answer is matching with this given solution, guys. Okay, so here one more diode is given to you. One more diode is given to you. Now here we are connecting a voltage source here, and this is connected with a 20 volt. So here we are having one switch, guys. Okay, and this switch is open, and this is connected with a voltage of value 40 volts. So this is 40 volts. This is our diode D3. This is 2 ampere. This is switch, and the value of this battery is 20 volt. This is what's a D2, and here one diode is given and this is D1, okay, and the current source is of 4 ampere, this is 10 volt, okay. So this circuit is given to you, okay, and for the given circuit you have 4 options, guys, okay. So the option is like, when the switch is open, the diode D1 will be on, D2 will be off, D3 will be on, so on, okay now, is it okay? So what you have to do, you have to check operating condition of the diode, or you have to check the conduction of the diode when the switch is open and when the switch is closed, guys, okay now. So for both the cases you have to calculate, you have to check the on or off condition of this diode, guys. Is it clear, yes or no? Now let us discuss one by one, guys. Let us discuss one by one. So first case, in the first case, case 1, I am discussing if a switch is off, guys. If switch is off, okay. So if this switch is off, and in this case I am assuming this is our reference point, guys. This is our reference point. Then what will happen, sir? Then this voltage will be 20 volt. Very good. And this voltage is 40 volts, okay, and this is 10 volts. This is our voltages. Now if I am talking about the current, guys, so as this current is given to you 4 ampere, so you can apply KCL here, or you can assume any current value here. Let us suppose this current is I1 and this current is I2, sir. You can assume any current, guys. Is it okay? Now if you write this is I1 and this is I2, so here how many current will flow here, guys? If I am talking about the current through the 20 volt, so this will be I1 and this is I2. So if you apply KCL here, so you can write this is I1 minus of 2, sir. Very good. Now as this current is 0 because this switch is open, so again we'll apply KCL at this point. So this is I2, this is 2, so this current will be how much, sir? So this is 2 plus of I2, sir. 2 plus of I2. Is it okay, yes or no? Is it okay, yes or no? Just tell me, please. If it is clear, then what we have to do, guys? Just we have to analyze conceptually only. Just think and comment about the on and off condition of this diode, guys. Is it okay now? So in the first case, what I am doing, in the first case I am just assuming, talking about this D3, sir. Just tell me one thing. So for D3, what we can say, just tell me about this current I1 and I2, okay na? So from here we can write I1 plus I2 is how much, sir? So this is 4 ampere. This is 4 ampere. Is it okay? And if it is okay, then what we can say, if I am talking about this I1 and I2, it may be positive or 0, sir. It can't be negative, because this is current through the diode only na. And if this is the current through the diode, okay, so if this is the current through the diode, either it will be positive or it may be what, guys? 0. Negative current will not be possible, because the current in the diode will be not flow when it is in the reverse bias, when it will be in the reverse bias. Is it clear, yes or no? Is it clear, yes or no? Because this is the normal diode only, okay. So here if I am talking about this I1 and I2, so it should be greater than or equal to 0 only. Here what we can say I1 should be greater than or equal to 0 and I2 is also greater than or equal to 0, guys. And if it is greater than or equal to 0, then in this case what we can say, it may be greater than or equal to 2, sir. Is it clear, yes or no? Okay, okay, let us check Manaria. Okay, so what we can say, so in this case we can say the current through this D3 is always positive. It means that D3 will be on, sir. Here D3 will be on. Is it correct, yes or no? Just tell me, please. Okay, just tell me, D3 will be on, yes or no? D1 and D2 is forward bias, not correct. Okay, let us see here. D3 will be on, yes or no? Just respond, please. Is it clear, yes or no? Respond, please, guys. Okay, is it clear? Now if it is clear, now I am talking about this D1 and D2, sir. So if I am talking about D1 and D2, what we can say here, guys? What we can say here, guys? Let us suppose both D1 and D2 are on, guys. Let us suppose both the diodes D1 and D2 are on, then what will happen? So if this D1 is on, because this is on, as this is on, so this will be sorted, sir, because this is ideal diode only, so this will be 40 volts. And if you are assuming D1 and D2 both are on, then what will happen, sir? So this will be again sorted, and here the voltage is 40 volts, sir. Here the voltage will be 40 volts. Okay, na? And if it is 40 volts, again if it is sorted, then what will happen? This is 20 and this is 40, which is not possible. Which is not possible, because in a single wire you are saying there is 20 volts and there is 40 volts and 20 volts. It is not possible, guys. So we can say D1 and D2 both will not on simultaneously. It is not possible, both will not on simultaneously, sir. So we have to check, guys. We have to check. So let us suppose D1 is on, then what will happen? If D1 is on, then what will happen, sir? This will be sorted. If the D1 is on, this will be sorted. So here the potential will be 40. And if it is 40, it is the 20, then again it will be on. So again we can say D1 will not be on, sir. So obviously this will be off. Then in this case D1 will be off. Okay. Then what about, sir? So when it will be off, so it will be on, sir, because in D1 and D2 one will be on. So if this is on, so this will be 20, so this will be 20. If this is 20, this is 40, so basically this will be on. It means that it is satisfying all the conditions. It is satisfying all the conditions. Is it clear, yes or no? Just tell me, please. Is it clear, yes or no? Respond, please, guys. Okay, is it clear? Very good. Now let us suppose, I'm just assuming case 2, guys. In case 2, what we are assuming, guys, if a switch is on, and when the switch is on, then what will happen, sir? When the switch is on, then what will happen? So if this switch will on, sir, then this will be how much? This will be 0 volt. Let us suppose, this will be 0 volt. I am just changing the color, guys. Okay. So this will be 0 volt. So here if this is 0, and if I am talking about this zener, this is 40. So here 0, here it is 40. So obviously this D3 will be off, guys. So in this case we can say D3 will be off, guys. D3 will be off. Is it clear, yes or no? Just tell me, please. Is it clear, yes or no? Just tell me, please. And if this D3 is off, what we can write here? Again, I am just talking about D1 and D2, sir. So if I am talking about this D1, let us suppose again this D1 and D2 both are on, guys. Okay, now? And if both are on, so obviously it will be sorted. If it will be sorted, so this value will be 0, sir. This value will be 0. And here again, as we have, this is 20 volt, this is 0, and you are assuming this is on. It means that this is in this circuit. Here we have 0, here we have 20, which is not possible again. And if it is not possible, so we can say again this diode D1 and D2 will not on simultaneously, guys. Is it clear, yes or no? Is it clear to all, yes or no? Just tell me, please. Very good. Okay, so let us see an area. Okay, so here what we have to check, guys. So let us suppose this D2 is on, guys. In this case, I am assuming D2 is on, and if D2 is on, this will be 20. Okay, now. So this will be 20. If D2 is on, this will be 20, and here we have 0. So basically this D1 will be on. So again it is not possible. Now what we can say here? What we can say here, guys? So here if I am assuming this D1 is on, if this D1 is on, then this will be sorted, guys. If this is sorted, so here we have 0 volt, and if we have 0 volt here, 20 volt here, so D2 will be off, sir. So this is the correct condition. So D1 is on, D2 is off. We can write D1 is on and D2 will be off, sir. D2 will be off. Is it clear, yes or no? Is it clear, yes or no? So this is the condition, guys. So what is the condition? So if I am talking about D3, D3 is off, D1 is on, and D2 is off when the switch is on, guys. When the switch is on. Now in the previous case, what we have, so in the previous case, if the switch is off, then this is the condition, guys. D3 will be on, D1 will be off, and D2 will be on, guys. Is it clear, yes or no? Very good. Very good. Very good. Okay. Now, so this is the last question from the analog electronics, guys. Okay. I am writing here. So here in this question, what you have given, guys. So again, this is repeated type of questions. Okay. This is repeated type of questions, guys. So we have one op-amp circuit, okay, and here a AC source is connected across this, guys, okay, of the value 100 sin 100t, okay, and this is grounded. This is our positive terminal, this is negative terminal, and V plus and V minus is given to you. So this is minus 15 and this is plus 15, guys, and here one resistor is connected with a diode, let us suppose D1. So this is D1 and the value of this is R and this is R, guys, and here a Zener diode is connected and a normal diode is also connected, okay, and this is V0, and you have given for the circuit given Zener breakdown voltage is 5 volts, guys, 5 volts, and the op-amp is ideal, then again you have yes, again very good, it is inverting only. So again we have 4 options, guys, okay, in the 4 option you have given V0 max is equal to something, V0 minimum is something, okay, so just we have to calculate V0 max and V0 mean value, okay. So let us write this. So here what we have to do, guys, so let us suppose this is Vi, guys, so this is our Vi, okay, and as the op-amp is ideal, so as this is 0, so this will be 0, guys, okay. So here just by seeing this circuit, what is say, guys, so this is inverting circuit only, this is inverting op-amp only, inverting op-amp, and as we know for inverting op-amp there is 180 degree of phase difference, sir, in the input and out. Is it clear, yes or no? Is it clear, yes or no? And if it is clear, so we can take 2 cases here. So in the case 1, what we can say, so for case 1, let us suppose if V input is greater than 0, guys, if V input is greater than 0, then obviously what will happen, sir, V output will be negative, guys. For positive value of input, output will be negative. So this will be what, sir? This voltage will be negative, sir. And if this voltage will be negative, so obviously this diode will be off, and here this diode will be what, guys? This diode will be off or on, just tell me please. Sorry, so this will what happen, guys? So here we have some positive value, here negative value, so this will be on only, okay. And now if I am talking about this, so here we have negative, here we have positive, so this will be off, guys, this will be off, okay. So the circuit will look like this, just see here, the circuit will be replaced with this circuit, guys. So here the value is 100 sin 100t, okay, this is R, and here again this is R, okay, this is plus, this is minus, minus 15 volt, plus 15 volt, and this is V0. So directly we can write the value of V0, sir. So therefore we can write V0 is equal to, because this is inverting circuit, so we can write minus of R divided by R into Vi, which is equal to minus of Vi, which is equal to minus of 100 volts, sir. Minus of 100 volts. Now, if I'm talking about this value, guys, is this possible? Just tell me once. Just tell me, is this value is possible? So it's very simple, sir. It is not possible because V set is given to you. Plus V set and minus V set is given to you. So this circuit will be, this op amp will be in saturation, and the value of V naught in this case is equal to how much, sir? So this is minus of V naught, minus of 15 only. Okay, so we can say V naught will be V naught set, and the value is minus of 15 volts, guys. Minus of 15 volts. Is it clear, yes or no? No, it's not 15, it's minus 15. Is it clear? Is it clear, yes or no? Just tell me please, guys. Okay, so this is the first case. Now what we have to do, we have to check this in the second case, guys. Okay, so what will be the second case? So in the second case, we can check by assuming this input voltage is, by assuming the input voltage negative, guys. Is it okay now? So let us take in case 2, I am assuming if V input is negative, sir, and if again if V input is negative, then what will happen, sir? If V input will be negative, so as there is 180 degree of phase difference, then we can write the output, which is V naught, will be positive, sir. Is it clear? And if this V naught will be positive, it means that what will happen, sir? This will be positive, and if this will be positive, we can say this is 0. If I am opening this, so this will be 0, and this is some positive value. So obviously this diode will be operate in off condition, sir. And if I am talking about this diode D2, then what will happen? So this is positive value, this is some 0 value. So again this will be on, and if it is on, I am just talking about this Zener diode. What will happen to this Zener diode, sir? Just tell me please. So here you are providing 100 volts, sir. 100 volt here, okay now, and here what is this? So this is V naught. Obviously as this is amplifier, so this will amplify, guys, and this V naught will be greater than this value, okay now. So here it will operate in what, guys? Breakdown region, okay now, and it will providing VVR, okay now, in okay. So this will be in breakdown region. It means that if I am talking about this circuit, guys, so it will look like, okay, so here what we have, yeah, so we have this circuit. So this is V input, and because just see, as this is off, so this will be open only, so no need to write that. So here we have only what, guys? Zener diode, which is in operating in the breakdown region. So this will be our resultant value. Is it okay? This is plus, this is minus, and this value is 5 volt, which is plus and minus, guys. Okay, and this is R only. Now just write the, okay, is it clear, yes or no? So if I am talking about the value of V naught, so it's very simple now. We can easily write the value of V naught is nothing but, so just to write KVL here, you will get 5 volts, guys. So in the first case, what we got, so here I am writing for V input greater than 0, okay now, we are getting V naught is equal to minus 15, guys. For V input greater than 0, V naught is equal to minus of 15 volts, and for V input less than 0, V naught is how much, sir? 5 volts. So therefore we can write V naught max is equal to 5 volts, and V naught mean is equal to how much? So this is minus of 15 volts. So these options are correct only. So this is the correct option, guys. Exactly, very good. So minus 15 and 5, this is the correct. Okay, so I hope it is very clear to all of you. Okay, So this is all from network and analog electronics, guys. Okay. Now Bipin sir is coming with the core subjects. Okay. So just we continue, guys. Okay. Yeah.
Thank you
Just
so much, Subho sir. Your explanation is just amazing. Thank you, sir. So guys, I'm ready with some questions of power system. I hope you have made them, you have solved them correctly. So I have some questions. Just check your answer whether you have done correctly or not. And if there is any mistake in the data, just let me know. Okay. So I have the very first question in which a power system network was given to us. So this is the power system network that we have. And here we have there is a bus in which a controlled source is given to us. Okay, we have a control source here at the bus. So this is the controlled current source. Okay, so this is our bus number 1, and the angle of this was also given. The phi value is theta 1 plus minus pi by 2. And what is theta? Theta is the angle of this bus voltage here. And this is bus number 2, whose P and Q ratings are specified. The values of P here, value of P is here is 200 megawatt, and the value of Q here is 40 MVAR. And the voltage and current magnitudes are V2 and theta 2. Here we have an infinite bus. Here we have an infinite bus. So at this infinite bus, the voltage and the angles are also specified. So this is bus number 3. Now what we have to say here, what we have to comment here, we were about to calculate the type of buses. So option A that we have, option A has B1 is a slack bus. Option B is B2 is, option A has B2, it is PV bus. B3 is PQ bus. Okay. And option B that we have, in option B we have B1 as PQ bus and B2 as PQ bus and B3 as slack bus. Okay. Option C that we have, in which we have option B1 or B1 as PV bus, B2 as PQ bus and B3 as slack bus. And in option 4 we have B1 as PV bus, B2 is also PV bus and B3 is a slack bus. Okay. So we have classified these buses during the revision classes, if you know. So if it is a PV bus, okay, what is known quantity and what is unknown quantity? If you know that, you will be able to solve this question very easily. So if it is a PV bus, P and B are known and del and Q are unknown. If it is a PQ bus, then P and Q are known and V and del are unknown. And if it is a slack bus, so for a slack bus, V and del are known and P and Q are unknown. So looking into this fact, this is a very important fact. If you know this fact, so if you see bus number 3, so in bus number 3 we know what is V and del, isn't it? So bus number 3 is a slack bus. Okay. And if you look at the bus number 2, so for bus number 2 we know what is the rating of P and Q. So for bus number 2 we know value of P and Q. And V and del are unknown. So it is what? It is a load bus or it is a PQ bus, isn't it? And here we have a control current source. So this bus will be what? This bus will be a PV bus. So which option is correct? I think option C. B1 is what? B1 is PV bus, B2 is PQ bus and B3 is slack bus. That is the correct option. So this is how you could have done this problem. Okay. I hope you have solved this problem correctly. The next problem that I have is, we were given a Y bus matrix. So a Y bus matrix was given to us, and the Y bus matrix is as follows: minus J15, J10 and J5 we have here, J10 and minus J13.5 and J4 we have here, and then we have J5, J4 and minus J8 we have. Okay, this is 1, 2 and 3. 3 buses we have. Now which option is not true, that is what we have to select here. Okay, which of the following is not true? So which of the following is not true? Option A is line charging capacitance. Okay, line charging capacitance I'm writing in short. Line charging capacitance is in all three lines. Is in all three lines. Option B is line charging capacitance is in line 2, 3 only, and shunt capacitor is in bus number 3. Option C is line charging capacitance is in 2, 3 only. Okay, line number 2, 3 only, and option D is line charging capacitance is in 2, 3 only, and shunt capacitor is in only 1. Okay, so we have to select which option is not correct. So we have to comment about the line charging capacitance and shunt capacitor, and it was given that there is no inductor in any of the buses. So guys, if you sum up this row, the summation of this row will be 0. Now if you sum up this particular row, the summation will be what? 10 plus 4, 14. So it will be j.5. Now if you sum up the third row, what you will get? Summation of third row will give you j of 1. Okay, so you can see bus number 2 and bus number 3. 2 and 3 have shunt capacitance, isn't it? 2 and 3 have shunt capacitance. So what we have to do, we have to comment which of the following is not true. So if you see, line charging capacitance is in all three lines. This is wrong, but as per asked in question, this is correct. Okay, second option is line charging capacitance is in line 2 and 3, and shunt capacitor is in bus 3 only. So this is also wrong. Okay, third is line charging capacitance is in 2, 3 only. So this is correct, but as per the question, this is wrong. Line charging capacitance is in 2, 3 only, and shunt capacitor is only 1. Shunt capacitor is not there in bus number 1. So this is also correct. So this was the second question. I hope each one of you have solved this correctly. Sir, one question was asked from microprocessor which is not in syllabus. Yes. Unfortunately, there was a question from microprocessor, and that is right now not in your syllabus. Okay, so these things happens. You can ignore those things. Okay, so after that we have one more question. So in this question, what was given to us? We have a power system network. The one line diagram is given to us. So this was the one line diagram. This is a motor. Okay, and this is the transformer that we have. This is bus number 2, this is bus number 1. And after that, what was given to us? After that, it was given that there is a fault at bus number 1. Okay, there is a line to line fault at bus number 1. Okay, at bus number 1 there was a line to line fault and positive, negative. Yes, definitely you will get bonus mark for that. Okay, I am very sure about that. So concentrate on this question. I hope you have solved this correctly. So there was a fault at bus number 1 and it was line to line fault, and you have been given positive, negative and zero sequence diagram are given. Okay, these diagrams are given to you. So these diagrams are given. What we have to do, we have to current the fault current for line to line fault. So guys, you know, fault current for line to line fault is what? It is equals to, the magnitude is equals to √3 upon x1 plus x2. So all you need is the value of x1 and x2. x0 has nothing to do here. Okay, so I am not drawing that diagram. So positive, negative sequence diagram was given to you. So this was the positive sequence diagram which I am right now drawing here. So this is the positive sequence diagram, and this is the bus number 1, this is bus number 2. Here your fault has taken place. This is J.1, this is J.1, and this is J.3 that I have. So what will be the equivalent x1? That will be equals to J.2 parallel J.3. So you will get J.12 here. Similarly, from the negative sequence diagram that is given to us, from the negative sequence diagram you can calculate these values as well, J.1, J.1, and this is J.3, and here is the fault. So x2 will be what? X2 will again be equals to J.2 parallel J.3, or you will get J.12. So x1 and x2 value you know. Now you have to come here and put the values. E is the pre-fault voltage, you can take it 1.12 plus 0.12. So this is coming out to be 7.21 per unit. I hope you have got the same answer, isn't it? I hope you have got the same answer. Now after that we have one more question, and the data of question is F1 is given to us, the incremental fuel cost 0.18 Pg1 square plus 40 Pg1 plus 120 rupees per hour, and F2 was also given to us. F2 was 0.2 Pg2 square plus 30 Pg2 plus 100 rupees per hour. These were these F1 and F2 given to us, and we have limits on Pg1 and Pg2 as well. This was from 0 to 350 megawatt. Correct me if the data is wrong. And this was from 0 to 300 megawatt. Okay. PD which is equals to Pg1 plus Pg2, this was given 290 megawatt. Okay. And in case 1 what do we have? In case 1 Pg1 is equals to 175 megawatt, and Pg2 is what? Pg2 is equals to 115 megawatt, and we are talking about the optimal solution. Okay, we are talking about optimal solution. So for optimal solution, what you will do? Deber F1 upon Deber Pg1, this is equals to Deber F2 dF2 upon dPg2. So after doing this, you will get the value of A, and the value of A will come out to be 1.02. So this is the first step that you have to do in this question. After doing this, what it has been said in this question, that A is increased to 10%. Okay, so if A is increased to 10%, so what will be the new value of A? It will be 1.1 of A old. Okay, so that will be 1.1 into 1.02. So ultimately A new will be what? That will be 1.122. Now you have to comment again for the same optimal solution, what will be the value of Pg1 and what will happen to Pg1 and total cost. What will happen to Pg1 and total cost? So what will happen? See guys, total cost F will be F1 plus F2, isn't it? So if A is increasing, that means F1 is increasing, so ultimately F will increase. So F, the total cost is going to increase, isn't it? There will be a total increase in the total cost. And after that, again putting this new value of A new, if you again apply this condition, Deber F1 upon Deber Pg1 or Db F2 upon dPg2, again if you will apply this condition by putting this new value of A, you will get the value of Pg1, which will be equals to 169.7 megawatt. So again you can see earlier Pg1 was 175 megawatt, now Pg1 is 169. So what happens? Pg1 decreases. Okay, so this is the answer for this question. I hope you have done this question, these questions. Yes, Lavanya, 169 approx. This is the answer. Okay, so Pg1 is decreasing and F is increasing. I hope you have clicked the same answer, isn't it? So these were the questions that I have received from the power system. I hope you have done all the questions correctly, isn't it? Very good, very good, very good, very good. So thank you so much.
Just do reply, guys. Audio video is clear. So I think many questions we have solved here: power system, power electronics, control system, signal, digital, engineering maths, aptitude, measurement. So student, I am having one more question that is very good question from signals. We are going to take the next question here. Okay. So the question is, if xt has a Fourier transform, this question is very good question it is. Xt has a Fourier transform x omega that is given in the question, and x omega value is given to you as a rectangular signal. The functional representation is given as a mode of omega less than equal to omega naught, and it is 0 when mode of omega is greater than omega naught. It means here options are also given, dear student. Option number A is at small t pi by 2 omega naught, the xt value will be 1 by pi. Option number B that is given in the question, xt tends to be a xt tends to be a impulse function. Xt tends to be a impulse function as omega naught goes to infinite. Okay. Option number C goes to x0 decreases as omega 0 increases. Okay, I am writing in a short form. Option number D says that at t equal to pi by 2 omega naught, xt value will be minus 1 by pi. Okay. So these are the options. Now student, how to approach? Do you know this is the functional representation x omega having the value 1 when mode of omega less than omega naught. So if you will make a graphical representation for the same, what you will get? You will get a rectangular pulse in the omega which is having the duration from minus omega naught to plus omega naught, and magnitude is 1, and this is with respect to omega, this is x omega. And if you have attended my classes of signals and system, I told many times the standard form is sine of at upon pi t. How many of you remember the standard form? Sine of at upon pi t in the time domain having the Fourier transform will be a rectangular pulse, and which is having the duration from minus a to plus a, whatever the t multiple, minus a to plus a. This is with respect to omega, this is 1 and this is x omega. So here, if I want to equate this x omega to x omega, then here a is replacing to omega naught. So it means the time domain signal will be sine omega 0 t upon pi t, and this is my x omega. So what is x omega given in the question? This x omega is given in the question, and it is nothing but this x omega. So corresponding x omega, this is my x of t. So now I am getting the x of t sine of omega naught into t upon pi into t. If I want to convert in sampling form, then also you can take pi here, you can multiply with omega naught, and you can do divide with omega naught, and t is also already there. So now this part and this part will become what, guys? This will be omega naught upon pi, and this will be your sampling of omega naught t, Now this is your x of t. Now student, here this is a very good question, I must say, because it will confuse many students here. There is a scope of confusion, because here if I will put t equal to 0 in the option, then what you will get? X0 will be, when you will put 0, sampling function at 0, sin t upon t is always 1. Do you know sin t upon t at limit t tends to 0 always 1? So sampling function at t equal to 0 always 1. It means x0 is equal to omega 0 upon pi. X0 equal to omega 0 upon pi we are getting, x0 equal to omega 0 upon pi, we are getting this, we are getting from here. But this value is what? X0. Here it is given that x0 decreases as omega 0 increases. No, because x0 is proportional to omega 0. Omega 0 increases, then x0 also increases. That is why option number C wrong. Now next step is, if you will put t equal to pi by omega naught, here if I will put t equal to, here is t na, if I will put pi by 2 omega naught, omega get cancelled out, and sin pi by 2. What is sin pi by 2, guys? 1 only. So what you will ultimately get? You will ultimately get omega 0 upon pi is already outside the bracket, sir. And here is sin omega 0 t sine omega 0 t upon omega 0 t, yes or no? And now what you are putting? You are putting at place of t pi by omega naught. Pi by omega naught, pi by omega naught, when you will put here pi by 2 omega naught. So here is omega 0 already cancel out, guys. 1 upon pi, this is pi, and t value is nothing but pi by 2 omega naught, pi by 2 omega naught, yes or no? So what you will get? You will get here pi t equal to pi by 2 omega naught. So here is pi, but this value is not equal to 1 by pi. It is the other value which is not equal to 1 by pi. It means option number this also wrong and this also wrong. I hope this part is clear to you guys, yes or no? Simply you can say that कि sir t का value pi by omega naught. So here t value pi by 2 omega naught, it means sin pi by 2 is 1, and when you will put t equal to pi by 2 omega naught, so 2 omega naught upon pi square. 2 omega naught upon pi square, it means this value will, this option wrong, this option wrong, this option wrong. Now many students will say that कि sir, because all the three options are wrong, option number B is correct. No, it is not actually a conceptual reason. You should also have a valid reason to make XT correct. Now tell me, my dear student, directly by observing the option, you will say that in this diagram, if I will make omega naught infinite, if in this diagram, if omega naught is infinity, then this rectangular pulse will become no more rectangular pulse, it will become a straight line. So when omega naught become infinite, this curve will be like this only, and when the curve will be like this, it is nothing but the DC value. And do you know which signal has Fourier transform 1? कौन सा सिग्नल ऐसा है जिसका फोरियर ट्रांसफॉर्म 1 होता है? तो वो होता है डेल टी. इट मीन्स टाइम डोमेन के अंदर अगर डेल टी होगा तो ही उसका फोरियर ट्रांसफॉर्म 1 होगा गाइस. तो इट मीन्स व्हेन ओमेगा 0 गोज टू इनफाइनाइट, दिस रेक्टेंगुलर पल्स विल बिकम ए डीसी वैल्यू 1, एंड 1 फोरियर ट्रांसफॉर्म किसका होता है? इम्पल्स का. सो दैट इज माय करेक्ट आंसर, ऑप्शन नंबर बी फॉर बॉम्बे ओनली. यस और नो? नाउ स्टूडेंट, आई एम हैविंग वन मोर लास्ट क्वेश्चन जो कि हम क्विकली कर लेते हैं, and it is very easy actually. So x of z value is given to you as a 4z upon z minus 1 by 5, z minus 2 by 3, and z minus 3. And here student, examiner, all the options are given, and examiner has given that DTFT of xn converges. Do you know student discrete time Fourier transform? Discrete time Fourier transform, do you know the discrete time Fourier transform DTFT? The DTFT will be only and only converges for absolutely stable signal, matlab bounded types of signal. It means to make the x of n stable, the ROC must include unity circle as far as ROC is concerned. How many poles we are having? 1 by 5 पे एक pole है sir, one pole is 1 by 5. One pole is at 2 by 3, yes sir, and one pole is at 3, one pole is at 3 sir, yes or no? Yes. It means we are having a 3 pole here sir. One pole is at 1 by 5, one pole is at 2 by 3, and one pole is at 3. Now you guys need to tell me where is the unity circle. This dot line is nothing but the unity circle, guy. Dot line is nothing but the unity circle. So because it is unity circle, now tell me which ROC will include this? Sir, the mode of Z should be less than 3 and it should be greater than 2 by 3. Out of 4 options, only one option will converge the unity circle. Only one ROC includes the unity circle, because to make the DTFT converges, the signal x of n should be absolutely summable or stable, and to make the signal stable, ROC must include imaginary axis in the Laplace transform, and here unity circle in the Z transform. So unity circle, so correct answer for this question is mode of Z should be greater than 2 by 3, and less than 3. So mode of Z should be greater than 2 by 3, less than 3. It is given in the option number B. I am not writing all the options here, guys. Okay, so right now 5:30, and we will be live very soon for the GATE 2023 electronics and communication analysis. Okay, guys. So be ready and please share the next session that going to be coming just after 15 to 20 minutes. Okay, guys. So bye bye. Thank you so much for watching live.